Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On wearedevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello everyone, thanks for joining and welcome to We Are Developers. Welcome to the Java Day. My name is Sead and I will be your host for this afternoon. We are looking forward to 4 great speakers from the Java universe. We will have the possibility to learn about the recent changes in Java. We will have the possibility to improve ourselves as developers in general, but of course especially in the Java world. And before we start, I would like to share a few remarks with you. So first of all, you know we all are in this horrible pandemic currently, and it's super challenging. So I hope that everyone is healthy and safe, that your families are healthy. I think we need to do our best out of this situation. It's also very challenging for us at We Are Developers. We were not able to host our physical World Congress last year, where we usually gather around 10,000 developers in person to network and engage with each other. But we also tried to make the best out of it. So we have hosted since the summertime more than 30 virtual events for you. We have gathered more than 40,000 people together who have watched these events. And I just want to say thank you. Thank you for staying loyal to us. Thank you for staying connected and engaged with the developer community. It's really something that makes us very proud and very thankful. So with that said, I can only promise that the Java Day is only the first event this year that we will host for you. We will have regular events in the future as well. And that means that we will host developer events every 2 weeks for different topics. So stay tuned, stay engaged, visit our website and watch out for the upcoming events as well. Next thing on my list is our code of conduct. As you know, we need to be nice to each other, which basically means that we need to treat other people the same way as we would like to be treated ourselves. And therefore we have prepared a short video for you. Okay, next thing, if you want to join the Q&A session, if you want to ask questions to the speaker, if you want to give feedback or to participate in the polls, if you are watching us currently from YouTube directly, then please shift to our website, wearedevelopers.com/live. There you have a Q&A tool right beside the live stream, so you can also ask questions. Otherwise, if you don't want to engage, of course, you can also watch on YouTube. And now it's actually time to introduce you to our first speaker. So let me go for a few seconds backstage to get Adam into the room. Hi Adam, how are you? Thanks for joining.
Oh, thank you. I'm doing best, actually. Thank you. And you?
That's nice to hear. Yeah, we are doing, as I said, the best out of the situation. We are very happy to have you here with us. And Adam, before we begin, I have to say, and also to recommend to the audience, there is a really nice podcast, and I would really recommend everyone to go to your website, to adam-bien.com. There's an interesting podcast, and you have this question that you often ask in the very beginning, your speakers, your guests, and I would like to turn the game around. So, Adam, what was your first computer?
My first computer was at ZX Spectrum 128K, which was actually an Amstrad. So this is when the Amstrad bought the Spectrum. Yeah, this was my first computer, and I really liked it.
And what did you do with it?
So, of course, games first, but then I thought creating a game is very easy, and this is how I learned to program. But it didn't work for years. So.
Okay, it didn't work because you were not able to program, or it didn't work because the computer didn't take it?
Long story short, the manual was in French, but I have no idea about French. Okay. So I only could, read the basic stuff, but not what it actually means. So it took a little bit of investigation to understand what's going on. Yeah.
So you didn't go actually the way to first learn French and then you just skipped that step, right?
Yes, because of pragmatic reasons.
Okay, yeah, okay, I understand totally. So Adam, I mean, you have been working with Java from the very beginning since JDK 1, so it's quite like more than 25 years. What will we learn from you today?
First, I'm not that old, so I'm 26. So, but what you will learn? I don't know whether you can learn specific. What I usually do, I try to keep everything simple. So hopefully you will see that you don't have to know a lot to be productive. And what I also would like to explain you today, this is actually my goal, how the next generation of Java runtimes happened. And this really surprised me. So I will try, to explain you with a little bit of code, how the new generation frameworks or runtimes, there's no more frameworks, runtimes are actually working, and what's the trick? And this is the entire idea of the session.
Okay, perfect. Thanks, Adam. I will now get out of the way, so the stage is yours.
Perfect. So, screen is shared, hopefully, and if you have any questions, feel free to ask during the show or after the show. I try, to answer all the questions online. Before we start, and I heard about code of conduct, you have to be nice, but I have to complain a little bit, because the last time I was in Vienna in person, I was really excited about the Sacher Torte. And this is in English, I guess, Sacher cake, I would assume. And how it looks like a chocolate cake, and this was my imagination. It will taste, like chocolate, Nutella, something like this. But this is actually a fraudulent cake, because it is something inside, like marmalade or jam or something. So it doesn't taste that chocolatey at all. So it is very fraudulent, sweets or cake. So people of Vienna, you have to complain, and just change the structure of the food, what I told you right now. So this was my complaint to the Vienna. This was my first conference in Vienna, so I always wanted to do this. And now we can start to be nice. Okay, so thank you for the invitation. I never attended the We Are Developers conference. I spent a lot of time in Vienna in various projects, but actually never was at a conference except JSF days 10 years ago, something like this. Okay, whatever I will do today, I will copy this or push it to the AirHacks repository. This is the workspace, and what I already did, I submitted the slides. And also welcome all the attendees from the meetup, from the We Are Developer meetup, and this meetup from AirHacks meetup. So we have 30 attendees from this meetup. So thank you for joining. And okay, now let's start the show. So familiar APIs on Kick-Ass runtimes. And this is, long story short, as you probably know, I work a lot with application servers, Java EE, and I really enjoy it still. And for me, the next generation happened 10 years ago. For me, the next generation was Java 6 and 7 and 8. There were small improvements, but I was no more that excited. I was just enjoyed, the Java 6 of things. And I thought, I'm happy and I will keep doing this, what I'm doing, and nothing exciting will happen. So I basically ignored all the thorntails, whitefly swarms on Payara micros, and I forgot what the name was of the Tommy application composer, I think. And I say, okay, this is, whether we will shave off 5 megs or not, no one cares. And something happened 2 years ago or 1.5 years ago, and this is actually the topic of the session. Okay, so I still enjoy Java and really enjoy Java. Actually, I have now many concurrent projects from different areas, and I still like it. And the only problem is the time. So if I had a little bit more time, life would be more fun. So what I do, I implement in backend proof of concept, perform code reviews, help my clients, and in the front end, I tend to delete frameworks, JavaScript frameworks, exactly what I did in Java 10 years ago. I also deleted a lot of Java frameworks and replaced them with standards. And this is what is now highly requested. So I'm deleting, various JavaScript frameworks and replacing them with basic stuff like web components and lit-HTML or Redux, stuff like that. Okay. So I have a blog. So thank you for mentioning that. It's basically my notepad. Then I have Airhacks FM podcast, where I invite people which I meet at conferences I have no time to speak with. And we start with what was your first computer and end up somewhere. So this is basically the podcast. And I have online workshops, virtual workshops called Airhacks Live. And these workshops are about various topics, and they happen online right now. And they happen, I would say, 3 times a year, because usually I will have to deliver far more private sessions. So I try to bundle, know all the interests, and deliver it once or a few times a year. So standard APIs. So people ask me now, what is your recipe to that? Know how you keep learning. So this is what the people or attendees sometimes ask me. And my answer is usually, I don't learn anything new. Actually, I try not to forget things. And my trick was that I stick with the standards. So actually, for 20 years, what I did was always the same, with exactly the same APIs. And the nice story is my clients like that. And all of them, no one had to migrate because of a new cool framework. And the cool story is, this is also the topic from today, they can actually copy their old stuff to the new stuff without any changes. And last year, there was a conference called JDD, and also online. And they invited me after 10 years. And what I did is I found the old code, which I wrote on stage of the conference. And this was like, the title of the talk was like Java 6 future is now, but is not evenly distributed yet. And what I did during the talk last year is I actually picked the old code. I found it on my machine and just started it first on the newest Whitefly and then on Quarkus, for instance. It worked without any problems. So what it means is no migrations, no upgrades. So from my perspective, the boring stuff, like the basic Java stuff, transactions, injection, I don't think there will be huge innovation there because everything is already invented. We get incremental improvements, very like smartphones or iPhones. It's also not like every iPhone or smartphone we get every year. Everyone is excited because a new iPhone or new Android is on the horizon, Google Pixel or whatever, or Samsung. They are just incremental. They are a little bit nicer, a little bit better camera. But whether my smartphone has 5 cameras or 25, I don't care, actually, right? And the same happened with Java EE. At the beginning, everyone was excited because there were huge revolutionary changes. We got annotations, and we could ditch the deployment descriptors, and everything was lighter, faster. But now already everything is very, very lean and fast. So what it means is no migration, no upgrades. It's very good if you learn API once. It's good for you. You don't have to relearn it over and over again. It's also good for your clients because they don't have to migrate just for fun, right? So then there are a huge amount of resources, books, and online platforms. And by the way, one of the reasons why I used, for instance, the Payara that much is because was built on Glassfish, and there were huge amounts of documentation for free out there. What happens now in my project? Jakarta is the foundation of most of my projects, and MicroProfile is the added value on cloud readiness. So actually today, before the show, in my project, what I'm doing right now is I'm creating a MicroProfile service which reads indirectly data from Oracle database, which is exposed Debezium to Kafka, and this reads the data, transforms the data, and there's some analytics with it. And there are probably 3 classes, and it starts in half a second, and it's very small solution and easy to understand. This looks like Pojo with 1 annotations called or 2 annotations, incoming and outgoing. So it means what you can do is you can actually apply your prior knowledge to the new stuff. This is important for me. And the Jakarta is, as I said, is more like the boring operating system, and MicroProfile is more like the newer stuff, mostly dictated by Cloud Native Foundation and all the specs outside of the Java Learn. Okay, so next generation runtimes, and now it's interesting. So, long story short, what happened was I actually recorded a screencast about Cloud Native Java for Red Hat, OpenShift, and then I met some engineers, and one of the engineers told me, "Hey, we implementing something new. It's based on microservices. You should take a look on this." And I said, "Okay, no, I'm not interested. I already reviewed the Whitefly Swarm and Thorntails, and this was just the same stuff repackaged differently, right?" And then it came out, of course, Quarkus, and I took a look on this, and I was actually saying, okay, I was really surprised about the idea what happens inside, and this is what I would like to share with you. So this is the slides and a little bit code because it's really hard to explain. So let's create a old-fashioned project. And I would call it current generation hello. So hello. Or Jakarta. So just briefly show you what happens here. So I would like to open with code. I wouldn't like to start the server because believe me, it will work. It's just to give you an impression what it actually is and was. So the entire deal of Jakarta, what I liked a lot was this here. So we only had actually 2, or still have, still in projects like this. So we have Jakarta 8 or 9 dependency and MicroProfile, and then nothing else. So this was basically, this is what you see right now. It's not like conference hack. This is what I use in production actually. So we have here a Maven POM with 2 API dependencies, and this is really completely, it doesn't matter to which application server you are deploying this. So it will work because you are not dependent on the application server. You are programming against the API. So, but the API, if you take a look on this is basically JAX-RS. And as you can see, we have the path pink, which is JAX-RS annotation with some inject. And this inject, by the way, comes from MicroProfile. And because it's a little bit cloud native, it already fits well to clouds. So what it means is it's container ready. So in current projects, I use this, for instance, on Azure, AKS, Azure Kubernetes Service, and on Amazon as well, and ECS Fargate, as well as an EKS, exactly this. So you can inject, properties from the environment entries from the container. So this is basically it, and override this with properties. So, and what I also have here, I have a system test, and the system test uses here MicroProfile. This is the client. It's just an interface which gets injected here and can be used on the fly. So this is basically it. So if I build this, and let's build a thing, let's switch to this. And the naming, the folder structure is just my convention, doesn't matter for today. But yeah, just build this, and you should never do the clean, so just do the package. So this is now correct Maven. So now, so what I have here is cgjk.war, and which I could deploy to all the servers, and I call that ThinWars because the ThinWars were small, and this one is small, it's 4K. So what meant is I really like the Java EE application servers because the war was small. I could run the the Docker container, and this was the uppermost layer, and the deployment to the clouds was crazy fast. So this is long story short. And the size of the application servers never really mattered because we shipped this to the cloud once and never had to reship it again, except we get new version of the application server. Also, this was great for security our projects because we didn't have to rescan our entire application over and over again. Oh, we had to rescan our entire application, but our entire application is here within the war and is clearly separated from the application server runtime. So the application server runtime was scanned once, and if we found something, we complained. Usually my clients in critical projects had commercial contracts with the providers, and they got fixed or not, but this was not our problem. So this was clearly separated. So the separation between the application logic and infrastructure was big deal, or is still big deal in my projects. So this is about the current state of the thing. So now what happened was, so I took a look at Quarkus. So let's start Quarkus. Exactly. So create. And now call it AirHacks. And now Quarkus is Quarkus next generation. Now call it this. And to add REST easy is enough. And yes. Okay, so what happened was I didn't use my own archetype. I just used the Maven plugin, which ships with Quarkus. And now I'm still in QNG. So I would like to open that and take a look what happens here. So now the Maven is a little bit too long for my impression. And this was also my feedback. I get crazy. This is a way more complicated what I know from Java EE, but for a reason. And so I would like to explain a little bit what happens behind the scenes. But more importantly, if you take a look at this is exactly the same API I always had. So as developer, actually, I don't have to relearn anything. It just comes to know whatever I did before. It runs right now on different runtime, which is actually a very big deal. Because in 2020, last year, we had a lot of migration projects and between runtimes, and this was not a huge problem. So now we have that. So what's the deal? So if I build this, now let's build this Maven package. And there's, of course, nice developer experience, but let's do this. So the system test, we can actually delete. But yeah. Not a topic of today, not today's topic. So let's speed this up. Source-Java. Now it is a little bit faster. Forgot clean. You see? Now we are talking. Okay. So now everything is clean and built. So we have the runner. And the question is, what's the difference to before? So now, what happens behind the scenes is there is a runner here, and the runner is a jar. So which is interesting because what I told you before, I was really happy that we have the clear separation between the war in the infrastructure, and here we have there seems like there is no separation. And what I would like to check how big this thing is. And the war, sorry, this is in the target. And the runner is 234K kilobytes. So this is the size of the runner. So which is actually, you can argue 50 times larger than the war counterpart. So, but it's just too small to be, the entire runtime. So you can ask, what's going on? So, and this is a little bit cheating what happens here, because if you go to the lib and take a look what happens here, and you can see that in the lib folder, there is a huge amount now of jar dependencies. So what we can do, I will just try Sometimes it works. So wait a sec. So, and I would like to open this. So let's do this. And I would like to decompile my runner and see what happens. Okay, so what you can see here, there is manifest, which is quite interesting because if we take a look at the manifest, you see that this runner points to the libs. So if you look closely, there's lib/iosmori and so forth. So what it means is we still have the separation, which is amazing. So what it means, okay, this is one jar, but from the beginning, the application logic is clearly separated from the runtime. So the runner is the runtime, and the application logic is this is the runtime, and the infrastructure is inside the lib. Okay, so we have here the AirHacks, the greetings resource, and there is also the greetings beam. Okay, so what it means is what the first observation was in microservice or in cloud native world. What people don't do anymore, they don't ship multiple wars to a single application server. So there is one-to-one relation between the application server and the war. And this was in my case also for a long time. I did it this way. I think, I don't know, 7-8 years, all my projects were like that. But my problem was a little bit the application servers were small enough, so there was no reason for optimization. But what they did, if we start from scratch, we will not allow multiple jars to be deployed at once. There is one runtime, one server, period. So if you think about this, okay, this is nothing revolutionary, but what with that I can optimize. We can say, okay, if there is only one-to-one relation, there is no need for runtime deployment. So what it means is, if we ship the war to Whitefly, Payara, OpenLiberty, or wherever you like, what the application server does, it watches a folder periodically every 5 seconds, and then if it finds a war, it has to read the war. It has to unzip the war. Then because it's just these classes, it tries to find the deployment descriptors. It reads the deployment descriptors, uses the information from the deployment descriptors, instantiates classes using reflection loaded by a specific class loader dictated by Java standard for isolation. And these classes are loaded on the fly, which means is because of the reflection and the dynamic behavior, we lose performance. So actually all enterprise frameworks are like this. So they use a lot of reflection to be configurable and runtime and dynamic. So what Quarkus did is they said, okay, not with us. So what we are doing is we try, because there's one-to-one relation, we don't need the dynamic behavior anymore. So this is actually the main idea of the entire thing. If I understood this 1.5 years ago, I said, okay, this is the future. Because the first time something is simpler than before, and this is, highly optimized. It's not like, the optimization is 10 to 15%. It's more like 50% comparing not only, to enterprise Java service, also compared to even Tomcat. So this is what we are talking here. So plain Tomcat is actually larger than this. Okay, so we have that. So now a little bit more experimenting. So what I would like to do is, I would like just create here a greeter Java. And I will have to annotate the greeter string opinion. Just do this and say here, return Zaha is not good. So, and of course, to be code of conduct. Sorry. Okay, so we have that, and then I would like to inject this. So let's inject the Zaha torte is cake to my greeter, and then do here something this greeter opinion. So, and this should be Vienna. Okay, we have something like this. Now, what I would like to do is just to build this clean package, and I will probably have to to decompile it once again. So yeah, let's see. Oh, perfect. This is here. Let's see. And okay. So we have the bean. And let's see here, greetings resource.greeter. So this is exactly the point here. And we have greetings resource greeter. This injection point was transformed into the generated code like that and like this. So what it means is usually application servers and enterprise frameworks, whatever, they would use reflection to set the reference. So what I mean by reflection is get declared fields, just set, and then put the value. And the reflection is the slowest thing you can get in Java. So what Quarkus tries to do is tries to avoid injection, reflection, and injects this by generated code, which is really fast, and you can avoid all the dynamic behavior. So what it also means is that you get most of the problems at build time. So what it means is it optimizes a lot at build time. So let's see whether we can destroy that. Let's say greeter interface. This is what I saw a lot in projects. Everything had to have an interface. So let's do this implements greeter interface. And the greeter has here a method. This is an interface. Greeter interface has to be an interface with a method opinion, and let's do it also dependent. And then I would like to create, a nice greeter Java with, it's also dependent, and then implements the interface, implements the greeter interface, okay, and then build that. Nice greeter says Sache is great. Okay, so I have it. Now, what I have to do is I would like to inject now my greeter interface here, which cannot work because there are two possibilities. So now, if I build this clean package, hopefully, I never tried it actually, but this was the expected behavior. So what I see is, actually I see my familiar dependency injection error, what I also would get from Whitefly. It looks identical, but I get it at the build time. So that's the trick. So because Quarkus already generates all the code which was actually executed at runtime, at build time, I get all the possible errors at build time, not at runtime, which is perfect. So okay, now try to fix it again. Greeter, and remove this, and then I hope it should work. So what it means is, with this observation that we try to optimize as much as possible at build time, you can eliminate, class loaders, reflections, scanning, and make the entire runtime linear. So now it built the thing again. And so what it means is the startup time is usually very good. So if I run it, jar target, what was the name? QNG runner something, runner. So let's start it. So it started. So this was actually faster than I expected. 0.6 seconds. Usually the first start is like 1 second or something. So and this is the behavior of just stock OpenJDK 11. Starts in 0.6 seconds. So what you also can do is here, you can say, I would like to run it Quarkus in dev mode. And now if we are here, I can go to local host 8080, and we are here. So, and I think it was pink, so let's see. So this was, no, hello rest easy. So let's change this to we are developers, which is equally to my tool called what I wrote. So I can see we are developers once again. So let's see. Wait a second. So let's do this. So Vienna Sache is not good, sorry. So and actually we can say is not the best. So it's not the best. And if we do it again, it's not the best. And what you see behind the scenes is actually a complete reload of the applications that fast that it doesn't matter. So there's no crazy stuff. So now the next consequence, if we are like this, so what if this is very simple and we generate the code, we know all the dependencies, and also you remember the deployment descriptors. The problem with the deployment descriptors is you have to write XML, they are read, and they're also slow. They have to be parsed by XML parser and so forth. What Quarkus does, actually the Quarkus extensions, they are reading the deployment descriptors and generated bytecode in advance. So then they don't have to be reread at runtime, which is even better because it's also good for performance. Now, about memory consumption, very low. So I did it several times, so it's smaller than Tomcat or Jetty. Okay, we have it. Now, of course, this is the. So what I do usually, I run Quarkus in production right now in JVM mode, exactly like this. But this is now the typically the conference show. What I can do, I can say clean install -p native. And then it runs the entire thing as a native image. So what we learned was Quarkus. But thankfully, Quarkus is not alone. There's another nice project called Helidon. It's very similar to Quarkus, but it comes with complete different ideas or goals. So let's see what it actually is. And and this is interesting here. It ships with a command line utility with which I can install the entire thing from scratch. So let's install the here. So now I'm downloading. I already have it on my machine, but just for you. So now it was downloaded. And by the way, I also interviewed on my podcast the engineers from Helidon, and this was one question. We had a chat exactly about the command line utility here. Chmod a plus x, the Helidon, x not y. So now it's executable. So I can now execute the Helidon. As you can see, it responds immediately. The nice story is the Helidon command line utility is written in Java, is also available as a jar, but it was compiled with GraalVM to a native image. So it looks like a Go library. So no dependency, a single executable, which is really nice. So with Helidon, I get very similar experience. So what I can say is I would like to start a Helidon project. And it asked me, would you like to start with plain standard edition, which is faster, smaller, but a little bit more proprietary because there's a little bit of Helidon, how to call it, Helidon APIs, which are not standardized, or microprofile, and of course microprofile, because, I forgot to, let's say, I would like to be a bear. Exactly, and project name POC, Ahex is great, and the POC as well, the snapshot. No look. Okay, now my computer goes crazy. And the reason is, I think it took longer than expected, but what you see here, there is this snapshot runner, and I can run the runner now with runner. And this is normal Java. This is just, this was the start. It starts in 0.022 seconds. So this is the start time. So, but enough Quarkus. Now let's focus on Helidon. So Helidon comes with two modes, SE and microprofile. And by the way, I get often questions on the Micronode. What's my opinion about Micronode? So Micronode was one of the first which introduced the idea of the GraalVM optimizations. But the main developer of Micronode, called Graham Roche, is working now for Helidon team, and they are merging more or less Micronode with Helidon. So we get, already the data repository from Micronode is already usable in Helidon. So this also great news actually, because there was a huge interest in Micronode. Okay, so now the Helidon. So we created a project with that, and okay, so let's take a look at the name was POC. Okay, so let's open the IDE here. My IDE is Visual Studio Code, it's just a plain editor. Okay, so the POM XML is shorter, which is fortunate. And what's interesting as well, it ships with all the microprofile dependencies at once. In Quarkus case, I had to add, the extensions, like for instance, I would like to have the matrix, the Prometheus matrix, small array matrix. I would have to add the Open API, and this ships with everything included. So there's a little bit different philosophy. My impression is Quarkus focuses on very fast start time, and Helidon focuses more on runtime performance. So this is like, they're different focus. But from the API perspective, it's exactly the same. As you can see, JAX-RS again, exactly the same as application servers 15 years ago, and path greet and inject, which is they use the here constructor injection, which I don't like. I would like, it's too much code, just use this here. But this is just how you like to develop. And this is basically it. This is one class with the POM, and you could start this exactly the same. So let's do this. So let's create this project, clean package. And the tests, so the Quarkus tests are based on own Quarkus test, more or less framework. And these tests are using a little bit different, as you can see. Quarkus started as runtime from the beginning, and Helidon is more like a library where with server create.start, you can decide on which point of the application you can launch Helidon. Actually, what you could actually do is you could start Helidon inside a JavaFX application, if you like. Doesn't make a lot of sense, but it would work. And for what this is great, of course, for batch processing, right? So now Quarkus is already solved problem. So I use Quarkus a lot for command line interface utilities, and Helidon was capable from the beginning of doing this. So what they are doing here is they are starting the Helidon before all, once the entire server. They store the server here. And then in test, they just use no stock JAX-RS API again. So you don't have the familiar APIs again. So the same story again. And okay, so now we build the project. So how this looks like. And I actually forgot. No, there is no server running. So with that, target java -jar, I think pork.jar, java -jar pork.jar. And this is the cold start of Helidon. So it starts a little bit slower in 2 seconds. Glassfish was Glassfish. Whitefly was half a second. And why I said Glassfish, this Helidon uses is based on Jersey libraries. Is similar to Glassfish. And Quarkus is more similar to Whitefly. So they're using a lot, of Whitefly dependencies. So it's not like these servers are reinvented everything from scratch. Both servers are based, on 10, 15 years experience. So there's actually nothing really new or proven technologies repackaged and re-optimized. As you can also see is that CDI, config, fault tolerance, health, JAX-RS metrics, Open API, security, server, and tracing are activated per default. So it starts in 2 seconds with the entire microprofile activated. In Quarkus case, it started just with JAX-RS, and I would have to reactivate all the APIs. So what it means is, because it's microprofile, hopefully it works. it should listen to health. Localhost, this is wrong, localhost, and it does. So this is the response from the server. I get the liveness and readiness probe. So let's see health live. This is the liveness probe, and this is readiness probe. What I also get are the metrics, and the application metrics should be empty. And what I also know is that the Open API should be the Open API endpoint, which also is. So it is generated on the fly. So Swagger UI ships out of the box. And this is actually true for all the runtimes. So I don't have to think whether I use Helidon or Quarkus, it behaves exactly the same for me. So I talk a lot about microprofile, and what microprofile is. If you take a look what it actually is, this is here, the best explanation is here. So as you can see, CDI2O, JSON-P, JAX-RS, JSON-B. So the lower layer is basically Jakarta E8 or Java E8. And then we get the goodness from the cloud native foundation. Like we get the metrics, which are based on open metrics. We get JSON Web Token propagation and JSON Web Token. We get the health, liveness and readiness probes, the config was the add inject, REST client injection, Open API was the endpoint Open API. And open tracing is distributed tracing, is the possibility that all the microprofile runtimes sending the traces or the spans to a central location, like for instance, Jaeger tracing. Okay, a question to the moderator. Are there no questions? Because what's up in Vienna? And I think we are almost over time. So, hello, studio. Are you alive?
Hey, hello. So we have 2 questions so far. First of all, thanks for your presentation. Are you finished already, or?
Depends on the questions, and I can go forever.
Okay, perfect. Then we go forever. Now we have 2 questions. One is when to use Spring REST over Jersey.
What? REST over Jersey?
Yeah, Spring.
Oh, Spring over Jersey. Yeah. I have to admit, I have almost no Spring experience. And what I know is that Spring tends to use I think it's called MVC templates or something. They're their own framework. And I never use Jersey directly either. This is the trick. This is the entire trick I just use JAX-RS. So what it means is what you saw today. I used JAX-RS application. I could actually move this application between Helidon, Quarkus, Payara, Whitefly without any changes. And in the case of Quarkus, the JAX-RS would be implemented by REST Easy. In the case of Helidon, by Jersey. Whitefly, REST Easy, Payara, Jersey. So you should never use Jersey directly.
Okay, perfect. Then there is a second one from Bruno. But I think he typed the name in the question field and the question in the name field, so it's cut it, but I will try to get the question. It's, is there any security-related difference between Quarkus and Helion, obviously?
Both spend a lot of time with security. And I know you should also listen to the episode with Thomas Lange about Helidon. So they have a particular, internal security concerns in Helidon. Also they try now to isolate all the components. And Quarkus is very well integrated as well with OpenID Connect, with how it's called Keycloak, and all the and the OpenID Connect providers. So this is a really nice integration. And so I don't know what security exactly means. So regarding the, let's say, support for authentication and authorization, I would say that the Quarkus is a little bit better supported because Red Hat also ships Keycloak, so you get tighter integration, and the tutorials are I would say easier to understand regarding Keycloak. And the overall security, it's also hard to tell, but what I know is that the Helidon developers spend a lot of time, just about the internal implementation of the framework. And both are supporting JSON Web Token from MicroProfile, because both are supporting MicroProfile. And yeah, that's what I can tell you.
Yeah, okay. If it wouldn't make a difference for your project, what would you go with, Helion or Quarkus? Like just from a personal taste.
What I like really, yeah, personal is the problem a little bit also the clients, right? So, but what I liked in the Helidon case is the command line interface, and what I really also like is that it ships with one dependency, which fits more, my expectation. What I like in the Quarkus case, of course, is the startup times, and it is. Helidon is lesser known. So if everyone would like to have Quarkus right now. So if I go to a client and I mention Quarkus, I'm in. With Helidon, I have to spend a little bit more time explaining why Helidon, but both are comparable. And for my taste, I would, let's say, for an application which is a little bit more CLI-like, right? So where you need more control how to start the framework, I would pick Helidon. For other things, Quarkus. But this is really hard to tell. I got the question all the time, Whitefly or Payara or OpenLiberty, and this also was hard to answer because they were different, right? So I enjoyed in Payara the admin console. In Whitefly, had other, every server had pros and cons.
Okay, so there are no more questions. I mean, you can stop your screen sharing this already, and we can jump back to the split screen.
Maybe this was the last slide, I think. Yeah, the last slide was that what you saw is the GraalVM optimization, which is a consequence of the simplicity and the static, the static optimizations. And for me, is learn once, run everywhere. This is actually the cool story. I don't have to decide. I could actually start, a project with Helidon, and we are not satisfied, move to Quarkus or back to Payara. So this is actually the great stuff. And also, it still counts also in some projects in Vienna, and they are highly security critical, and they really would like to buy support for the pieces they're running. And for this particular case, I say, okay, then pick Helidon, then you can buy support from Oracle, or pick Quarkus, you can buy support from Red Hat, I don't care. And from developer perspective, they are almost identical. Yeah, and if you would like to join my workshops, the next one are in March. So if you like, there will be the next one is about Kafka and Quarkus actually, and a little bit of Helidon, and yeah. So thank you. So and stop joining.
Thank you, Eden. I have one last question from myself. Since I've also some experience with Java. It was the first programming language I learned, and I did some project. I'm not an expert, but was quite impressive your presentation. I think that the audience could learn something out of it and get some takeaways. There is people out there who say that Java is a dying language because, it's complex and big and there is some easier and maybe sexier stuff and so on. What do you answer these people?
I hear that a lot, back then. And I would say around Java, when was it? When Ruby on Rails was around. This was the high times of such, opinions. So Java is dying. Why I'm doing Java? Ruby on Rails is, the next thing you should focus on. I assume it was 2006, right? So the Ruby on Rails high times.
Yeah, around that, yeah.
Yeah, and I would say what happens right now with Java is actually Oracle does a great job in the Java corner, and what is also excellent is GraalVM. And not what I showed you today with GraalVM, where you can create a Go-like libraries. More like what you get out of that is also multilingual environment. So what I already did is I loaded into GraalVM a JavaScript library I needed. This was Mustache, and combined it with Java, and I could actually create from the entire thing the Go-like image and start it. So from the innovation perspective, I would say Java is pretty far. So the perception, probably the Java is now so popular that if you start a programming language, it's just easier to impress your colleagues if you know something strange. This was always the case, right? So I don't know. We had exactly the same discussion with Scala. You remember that? So why I'm not doing Scala? And even the company who did Scala, they moved away from Scala, which actually the types have renamed themselves and to Lightbend, I think, and they do Java again. And this is like, if you or you have to have reasons to do something else. So if you're happy what you are doing with Java, and let's say if I would switch to Go, my expectation would be something would be better, faster, or whatever, right? So if if there is no difference, so why to move? And if you start with Java, we shouldn't forget how many books and tutorials we already have. So Java is unbeatable, I would say. What changed, of course, in browser, right? So JavaScript 1, and I don't try to run applets in the browser, of course, but on the server, Java is still a thing, I would say.
Okay, I think.
What's your impression? So you are a Java starter. So what's your impression about the Java thing?
To be honest, I think it's kind of timeless because you can do everything with it. There is maybe for specific stuff other possibilities that may work better, faster, whatever. But Java is kind of universal. You can use it for everything, and it's a big benefit. Yeah, and you also kind of tend to do it the right way then, right?
But even huge conferences like We Are Developers have a Java Day, right?
Exactly. So that's a good last word, I think. I see we are short on time. Gary here is freaking out already, but
okay.
Yeah. So Adam, thank you so much. It was really a pleasure having you. So we hope that you will join us again in the future. We will definitely invite you again. And for all the others, we are actually in a couple of minutes, in 3 or 4 minutes, coming back with Holly. Again, of course, to speak about Java. So grab a quick coffee, espresso maybe, and see you again in 3 minutes.
Thank you.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On wearedevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello, welcome back. Holly is with us now. Holly is from IBM, and we are pretty much looking forward to her presentation, to her talk. Holly, thanks for joining. How are you today?
Oh, my pleasure. Thank you for inviting me.
Thanks. So, Holly, I don't want to take your time. So, the stage is yours. You can share your screen, and I'm sure the audience will enjoy it.
Thank you. Cool. So I want to talk about cloud chaos and microservices mayhem. And I think in general, I feel so lucky to be a developer. I love being a developer. I think we have one of the best jobs there is. And I think as well, this is a great time to be a developer because I try and be grateful for things, and the cloud is definitely something to be grateful for. It's made so many things so much easier, and it's just enabled all of this technical innovation. And particularly as we're in lockdown, we're really realizing how useful it is to have things accessible in the cloud rather than somewhere more local. But although I think the cloud is great, there are some challenges with the cloud, and there are some things that we get electrocuted in the cloud when we try and do things. I want to talk about some of these things that we just need to change how we do things in order to adapt to the cloud. So when we look at the year coming up, what kind of skills do we need to be getting good at this year? Some of them are things that continuations of skills that we needed in 2021, like hand washing. We really need to, it wasn't an important career skill, now it is. But more generally, as developers, what we tend to be writing now is apps. But in 2021, it's not enough to just write the app and throw it over the wall. You really also need to be looking at the ops side of it. So as well as writing this amazing code that's going to hopefully enable somebody to do something that they couldn't do before, you need to be running this thing. And when you do ops and apps, then basically what you've got is DevOps. And, we've been talking about DevOps for a long time. I'm not sure we've ever, very few organizations have done it really successfully in that true sense of combining apps and ops, but it's something that we need to keep pushing on as an industry. But of course, in 2021, we've been talking about DevOps for a while. So DevOps on its own isn't enough. Security for a while has been sort of going, what about us? We're nice too. We're really important. Please don't exclude us from this flow. One of the things about DevOps is getting that really close communication between the dev side and the ops side, and security absolutely need to be involved in that communication. And then, of course, you can go on from there, because then the business said, well, wait a minute, what about us? We're the most important people here. We're the thing that drives the whole thing. Please don't exclude us from the conversation. And that's absolutely right. And then you get design ops. And then you get these sort of really long ones where it's DevSec, biz, design ops. And then you just sort of think, what problem were we trying to solve anyway? But there is one of the ops variations that I do want to talk about, because I think I hadn't heard of it until last year, but I think it's going to become increasingly important, and that's FinOps. So I'll talk a bit more about FinOps, but FinOps really is applying that real-time information, that automation to your financial processes as well, and to particularly the financial processes that relate to your IT. So with the cloud, I think the reason that it sometimes causes problems is there's a whole bunch of practices and patterns that used to be the right thing to do. And then with the cloud, that turned a whole bunch of things upside down. And what used to be a good idea was suddenly a terrible idea. And what used to be a terrible idea was suddenly a good idea. So we sort of just have to adjust as an industry and unlearn things. And again, I think, that's kind of one of the really great things about our industry is that it does keep changing, is because it would be boring if we were doing the same thing all the time. So the fact that it's changing all the time, there's always new things to learn, it makes it kind of interesting and fun, or at least I think so. So let's talk about a few of the things that are really quite different in the cloud. One of them is just how we manage our instances. So there's sort of a good side and a bad side, because with the cloud, it makes it so easy to provision hardware. Instead of having to actually go out and buy something physical or fill in a really long requisition form, if you're lucky, you can just click a button and you've got hardware, which is amazing. And often that hardware is free because of the sort of the business models of the cloud providers. But just because it's free doesn't mean that somewhere something isn't using hardware, and that hardware does have a cost. Someone is paying for that hardware. And as well, that hardware, we provision things and then we use them for experiments. We forget to deprovision them, but they usually tend to just carry on going. And that has a couple of problems. One, it means we don't actually know what's going on. So when I was learning Kubernetes, I did what everybody would do, which is I tried it out. So I created a Kubernetes cluster, but then I had too much work in progress. So I got pulled away to other things. And it was 2 months later when I came back to this Kubernetes cluster. And because I was learning, I did sort of a fairly well-specced Kubernetes cluster. So this cluster was €1,000 a month. It had been sat there doing nothing except burning electricity for 2 months. And, I sort of realized, oh, that was maybe not so good. And it was a slightly awkward conversation with my boss. And this isn't just me. As an industry, we have a really bad problem with zombie servers and zombie processes. So these are things that maybe once upon a time, they were useful, but they stopped being useful a long time ago. And yet they still sort of shuffle through, someone else's data center, consuming resources. We may be paying for them, and they're definitely using electricity. So that's not so good. And this isn't just, a small problem. A team in 2017, they surveyed 16,000 servers, and they found a quarter of them were doing no useful work. And then they sort of said, well, how does this happen? No one sets out to create useless servers. And so they said, well, perhaps someone just forgot to turn them off. And yeah, that was what I did. So this is where FinOps comes in. So FinOps this isn't the official definition, but I like to think of FinOps really as figuring out who in your company forgot to turn off their cloud. So trying to get that information and that dynamic information about what's going on with your cloud bills, and so that you can assign the amount that you're being charged to the person who's using it. And then once you create that chain of traceability and accountability, then that makes it a lot easier to do things like remember to turn off a server, because you can actually see that you have this server and you can see that it's costing money. And of course, this is really good financially. It's also good environmentally, because it doesn't do the climate any good to have 20%, 25% of our servers just sat there burning electricity for no use. So another thing, I think that was probably the sort of the biggest change in the cloud, is that because they're somewhere else, we lose our servers. But there's other little things that are different as well. So tracing, it used to be that the best practice was that you would put your logs onto the file system, on the same file system as the thing that was running. And of course, in a cloud, if it goes down, the whole thing is going down and it's probably never coming back. So then all of a sudden, all of the logs that told you what the problem was were gone. So now we have to do things, all of a sudden we need logging as a service that we didn't need before, so we can externalize the logs. And a whole bunch of things that, I spent a long time because I used to help write the Webster application server, and I spent a long time writing file rolling logic so that it could roll the files for its logs and stuff. And all of that is now just completely different. Packaging as well. We used to have a lot of debate about what was the best way to package an application? Should we do it as a fat jar? So we package the application server, whether it's called an application server or not, in with the application. Should we do it as a really small jar that you just deploy to an existing instance? All of that conversation has just gone away, partly because Docker makes packaging so much easier, but also because when in the way that containers work is that you want to have just a very small layer that changes and the rest of it wants to stay the same. So you definitely want to bake your dependencies into the base image and then only have a small thing that's changing. Another thing that's changed, which I find really interesting, is performance requirements. So it used to be that a Java server, a lot of them would stay up for 6 months. So if something is staying up for 6 months, it doesn't really matter how long it takes to start up. It's kind of annoying for the developers if it takes a long time to start up. But what you really want to optimize for is throughput. How many transactions can you get through this system? How many users can it handle concurrently? But now, when we're in the cloud, these things come up and down a lot more often. And so that startup time, it's money, it's cloud compute that we're paying for. So we want to minimize that startup time. And also we can be a lot more specific about the requirements of our machine. So instead of just buying a great big piece of hardware, we have to say really precisely how much we need. And if we can get that smaller, that's money. So it's put a lot of different pressures on the middleware, on the application servers. And so I, as well as working on the Webster application server, I also used to work, help write the JVM, and I used to work on the performance of the JVM. And one of the questions that we used to get a lot is, why does my JVM have to compile my code at runtime? This is a throughput drag. Wouldn't it be way better if it would compile it ahead of time? And the answer to that was always no. Actually, compiling at runtime doesn't hurt your throughput. It helps your throughput, at least after you've done a warm-up, because it can optimize way more effectively with the knowledge that it gets at runtime. But now we're not trying to optimize throughput anymore. We're trying to optimize startup time, and we're trying to optimize memory. And so now all of a sudden, ahead of time compilation actually is a good idea. It always seemed like a good idea, and it wasn't. Now it seems like a good idea, and it is. And if you look at things like Quarkus, for example, Quarkus is taking advantage of ahead of time compilation. And that's one of the ways that it gets these ridiculous startup times and ridiculous memory footprints. So, you know, it can start up in milliseconds and it can use hardly any memory. There was, I heard a story that one of the Red Hat project managers was at a conference back when we had physical conferences, and they were on doing booth duty, and so they were demoing Quarkus to people, and they were a project manager, so there was a few little technical details that they'd forgotten about, and one of the technical details was maybe after demoing it to someone you should shut it down, and they just completely forgot that. At the end of the day, they discovered that they had 130 servers running on their machine, but the best thing about it is that they didn't notice until the end of the day, because their laptop could run 130 of these things without even having any problems. So that, you know, that sort of shows if you can do that on a laptop, you can do that in the cloud and pack them really tightly. Now we get back to the DevOps side of it. So it used to be that when we released software, we had to put them onto disks, and that was really expensive. You only wanted to do it maybe once a year, maybe once every other year. And your customers didn't want them more than once a year either. Now, of course, you know, so you'd have a really rigid release schedule, and it put a whole bunch of really horrible pressure on the developers, because if there was only one release a year, you wanted to make sure your feature was in that release. So you'd have, you know, sort of a mad rush to try and get your feature done in time for that release. Probably it would be pretty terrible. And so then there'd be sort of a series of bug fixes, but you wanted to get your foot in the door and then you could do the bug fixes. So that was bad for the developers. It really burnt them out. It was bad for the customers because they'd know that the first release of software they got was probably not good quality and they'd have to wait for a few more releases. I mean, we still see this sort of pattern, for example, you know, with Cyberpunk and that kind of thing, that there was a big push to get it out. And now we're seeing a patching cycle after the release. But I think that that is the exception. And the gaming industry, sort of operates on a different cadence to the rest of our software industry, where we do have much more regular release cycle, which means that the quality of the releases is higher because we do it more often. It seems backwards, but that's the way it actually plays out. And that release schedule is really important, because if you don't change that, you're not going to be able to change a whole bunch of other things. So I work for the IBM Garage, and we're sort of a consultancy organization, and we spoke to a large bank, and they said, oh, our legacy bank, our competitors are eating us up. We're moving too slowly. We think the problem is this big COBOL estate that we've got. We should modernize it, make microservices, because all the cool people are doing microservices. So then we asked them a few more questions, and they added that their release board only meets twice a year. At which point, it doesn't matter how many microservices you have, if your release board only meets twice a year, at most, you're going to release twice a year. And so then you're taking all of the hit of a microservices architecture without the benefits. So what are the benefits of a microservices architecture? Well, the one that we always think about and talk about is modularity. Microservices will give you modularity, but they're not a goal. They should be a means, and the means, and even modularity isn't a goal. Your goal has to be something like, we want to release more frequently, or we want to be able to test differently, or something other than we want to be modern, so we're going to use microservices, but we're going to keep everything else the same, because that just doesn't work. And I think particularly, we see this in our industry all the time, this sort of, some people call it cargo culting, this wishful mimicry, which is that we think if we pick up one part of the best practice, we'll get all of the benefits of the best practice, but that doesn't work. You have to pick up all of it. And sometimes the bit that's really obvious and visible, like the microservices, is maybe the thing that you want to pick up last, not the thing that you want to pick up first. And you do not have to be doing microservices just because you're on the cloud. You do not have to be doing microservices to take advantage of the cloud. And I think, sometimes we think, oh, I have to be doing microservices to be cloud native. You don't. And microservices have a cost. I was flown in to work with a troubled project. And I arrived, and pretty much the first thing they said to me was, every time we touch one microservice, all of the others break. And now, if you've been paying attention, you know that the point of microservices is that they're supposed to be independent and not coupled. The reality is often a bit different. And so instead of having these really decoupled things, you just end up with this distributed monolith. And the more you develop, the more you add to it. And the reason a distributed monolith is bad is, in a normal monolith, at least with Java, one of the things your compiler is going to give you is it's going to give you that type safety. It's going to give you that compile time checking. And if you call another component, it's going to execute. Whereas with microservices, you don't get that type safety unless you work for it. And if you try and call another component, it may be there, or it may not be there. It may run it, it may not. So you get this sort of increasing amounts of complexity, and you're just not getting anything for it because you're more and more coupled. As another sort of, this isn't a microservices story, but I think it really shows how we can get coupling and the kind of the destructive effects of coupling that might not show. This is the Mars Space Explorer, and it looks a little bit like it was made out of a bin liner and duct tape, but it was actually, a proper professional, very expensive project by NASA. And it had a rather sad fate, which is it was supposed to orbit around Mars. Instead, it went into Mars, and that was the end of the Mars Climate Explorer. And what happened? Why did this happen? Well, when they looked into the cause, they realized that there was two components. One was on Earth, one was on Mars. So you can't get more distributed than that. They were written by different teams, again, living the microservices dream. But the team that wrote the space component used metrics units. The team that wrote the ground unit used imperial units. So then that was bad. And in this case, obviously distributing did not help. They couldn't have been more distributed, and yet they still had this coupling, and it was a hidden coupling. And so just because you're distributed does not mean you're decoupled. We sometimes use these two words as synonyms. They are not synonyms. And there's a lot of reasons not to do microservices. So if you're a small team, you're probably not going to be having independent teams developing the independent microservices. So don't bother. If you have no plans, if you don't have the organizational, intestinal fortitude to release them independently, don't bother distributing them. And when you have microservices, they have to communicate with each other. That communication has to be secure. They have to have a way of doing service discovery. There's a whole bunch of things that you have to do. And service meshes are layers, little bits of infrastructure that help you do all of these things. At the moment, I think often when you say service mesh to someone, they go, "Ooh, no, that's too complicated. I don't want a service mesh." So, but those jobs still need to be done. So instead of using someone else's service mesh, basically you're going to roll your own service mesh. That may be better, but it's probably not going to be better. So just, do think about that. And finally, sometimes microservices should be one domain per microservice. And so if your domain model doesn't split nicely, if there's just all of these connections, maybe it should be one service. And in the project where every time they touched one microservice, all the others broke, when I looked into the code, I thought, this is kind of weird, because I saw the same code over and over and over again in each microservice, because there was this object model, and it was a big one. It had about 20 classes. Some of those classes had about 70 fields. And they didn't want to have the coupling of an external library. So instead, they cut and pasted the code between each microservice. But of course, that's still coupled. It's just that you can't see the coupling. But if one person corrected a typo in one microservice, all of the other microservices broke. They had no way of knowing that. So it was bad. And in this case, really, I think the solution probably was that they needed to have just one big service, or they needed to be really much more aggressive in trying to get each microservice with needing to have just a sliver of that object model. Because as it was, the microservices dream is that you have a whole bunch of little microservices, and each microservice has its own domain, and there's no connection between the domains of the microservices. That may be not realistic, but certainly what you don't want is the case we had in this case, which is that the domain is exactly shared across all of the microservices. So if you're going to get good at microservices, I mean, everybody, since microservices were first a thing, we've always said, if you're going to do microservices, you need to get really good at automation. You also need to get really good at testing, because you don't want to have a huge manual QA cycle before you can release any microservice, because then you lose that ability to release independently, which is the whole point of microservices. So the test pyramid is a really useful way of thinking about microservices testing. So at the top of the pyramid are integration tests. These give you great confidence that your code works, but they're really expensive to run and expensive to write. At the bottom of the test pyramid are unit tests. Those are really cheap to run, cheap to write. The only problem is they don't necessarily give you that much confidence that everything's working. In the middle is contract tests. So contract tests are cheaper to run than integration tests, but give you more confidence than unit tests. So you want all of them, but you want the most unit tests. And one of the really nice things to point out as well is, I'm a big fan of test-driven development, and you can do that at every level. So a good way of thinking about unit tests, or contract tests rather, is in terms of testing a fire alarm. This is not how I test my fire alarm. If you set a building on fire and the fire alarm goes beep, 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 you have great confidence that the fire alarm works, but the building is on fire. So instead, so yeah, check, fire alarm works, but. So instead, most fire alarms, they've got this little button that says test, and you push it. And ideally, you're supposed to push it once a week and confirm that it goes beep, beep, beep. And that's like unit testing a fire alarm. I know that the fire alarm goes beep, beep, beep. But what I don't have is that connection to say it goes beep, beep, beep if there's smoke, which is the thing I really care about. So this may, I do my fire alarm test once a week, but this probably isn't enough. I hope that someone somewhere has done that full integration test. And there's a middle ground. So what a lot of institutions do is they do need to take a bit more care over their fire alarm because more people depend on them. So they have these devices. It's kind of like a bucket on a stick, and it releases smoke. So you sort of wrap it around the fire alarm, and then you push the button and it releases smoke, and then it goes beep, beep, beep. So that gives you the confidence that the fire alarm will go beep, beep, beep if there's smoke without the trouble of setting your building on fire. So, job done. So let me show you how this looks in practice with some code. So I've got a simple little application here. This is the world's worst microservices application because instead of having 82 services, it's only got 2. Again, this is because it's sort of quite complicated to get a whole bunch of them running, and the same patterns of broken dependencies that you see with 82 services, you can see with 2 services. So I just have a front end and a back end. So I've got a front end, which is written in JavaScript, and I've got a back end, which is my BFF, which is written in Java. And so if I run my application, yes, you can see as well, I've got my front end running and I've got my back end running. So 2 independent services. So I thought a house is kind of a nice model for microservices because you have your data model, which is going from room to room, and it's getting something done to it in each room. So in this case, we've got our little person and they go from room to room. So if I reload it, you can see they wake up, their hair is a mess, then they go down to the bathroom, brush their hair, then they go to the kitchen, they get fat because they ate, and then they go back to bed and they fall asleep at the end of the day. So if I wanted to make this a more complex demo, I could have each room of the house be a separate microservice. And then if I wanted to show that I should be restricting the domain of each microservice so that I don't send the whole person from room to room, I could then do something where I say, in the kitchen, the only thing it actually affects is the stomach. Does the stomach get fat with food? So I could send only the stomach to the kitchen. Obviously, at that point, the metaphor breaks down because you couldn't send only a person's stomach to the kitchen. But that's where you want to be doing that that simplification to say the kitchen only needs the stomach. And that's why we're going to get the benefit of the microservices architecture instead of sending the person from room to room. And if I look at my data model that's coming out, I can see I've just got some JSON here. So I've got arms, eyes have a state which could be awake or sleep, hair has a state which could be combed or wild. Then then I've got a torso which has a state of hungry or full. So far so good. But that torso is kind of a fancy word. So I think I want to change it to stomach. I think that's going to be a bit easier to understand. So I can go and I can do a refactoring. And I can rename that to stomach. And because the IDE knows how everything is connected, when I do that refactoring, it should just rename everything. So my class that had been called torso is now called stomach. And so if I go and run it again, all good. But if I look at my data model, it's still called torso in the data model. What happened? Because of course I want to be consistent. I don't want it to be torso in the data model and stomach in the code, because that's going to be really confusing to maintain. And it's because I'm using JAX-RS. And so in my resident, the method is called getTorso. So in the JSON, it gets called torso. So let me just do a rename of this as well. So let's call that getStomach. So now what happens? If I look at my data model, whoops. Oh, I think it's restarting. Yeah, it's restarting. I was too fast. So if I look at my data model, now I've got a stomach. Hooray, successful refactoring. Let's just go and just do that last little check just to make sure that everything's okay. So in this table, I see stomach hungry, which is exactly what I want. If I look at my visualization, something's gone a bit wrong. So the visualization is looking for a file called stomach full. I only have a file called torso full. So I had this coupling between the file names and the data model that I hadn't really thought about when I changed the Java side. So now all of a sudden, my little refactoring has broken everything. So what can I do? So this is where contract testing comes in. So I've got unit tests here. And if I look at my I've got a unit test here, and it's using a mock of the wire. And so I can, that's good, but it bakes all my assumptions into the mock. I want something that's actually going to validate my assumptions. So I can do a test which is really similar to my unit test, but I can just call that resident table.contract.test. And I'm doing this to show that it's sort of quite very similar in structure. I do need to make a few little changes. So I need to rip out the HTTP mock, and I need to replace it with my mocking framework. I tend to use Pact. I like Pact because it works in JavaScript, Java, Ruby, PHP, Python. It's got bindings for a whole bunch of languages. So if you're doing that microservices, polyglot dream, you can use Pact. And Pact is doing a lot more than just like a Swagger verification. It actually, on your consumer, it's acting as a mock. So you tell it what you expect, it gives it back to you. So that's really handy. It saves you having to write a mock. On the provider, it's actually exercising it. And you can do some quite complex things. So you can say, if I call this API and I pass in this value, I expect that value back. So you're doing a functional test as well as just a syntax test. So in this case, because I want to be quick, I'm not going to type the whole thing out. I'm just going to show it as a little diff. So if I look at my diff here, oops, sorry, that is the, yeah. So I have to pull in a few Pact dependencies. I rip out my Axios dependencies, which is my HTTP mocking. And here I'm just going to do some specification to say, this is what I expect. The state could be awake or asleep, but if I call it, could you just give me awake? So I'm doing a few specifications like that. And then all the rest of it is actually really similar. So this is showing as different, I think, because of slight formatting change, but it's basically the same. So if I pull back in my contract test, then it will rerun my tests, and you can see that I've got my contract test, and structurally it was the exact same test as the unit tests, and you can see it's taking a while to run. So it's faster than a unit test. Sorry, it's slower than a unit test. It is faster than an integration test. So you want a smaller number of them. But when this does finish running, it's passed. So I said in my unit test, I expect it to have a torso. So that was in this expected result.json. I say I expect it to have a torso. So this is great. I've got some tests, but there's a little bit of a problem, which is that my tests are passing. And of course, my system is broken. So now I can share my contract from my consumer to my provider. How you'd normally do this is you'd maybe put it into source control, or you'd use a broker to share it, and that can also track versions and can track test results and that kind of thing. I'm going to be low tech, so I'm just going to copy it. So I'm going to copy my pact from my front end to my BFF. And now if I look in Eclipse, I can see I've got that source test resources. In there, I've got a pact. And when it opens the file, you can see I've got a JSON. So that's just a specification that was generated from my test saying, I expect you to have a torso and stateful if I call this API/resident. So now I need to write a test. So if I go back and pull it out of my Git history, I had this house contract test, and you can see it's really small. Basically, it's got a whole bunch of dependencies. I say I expect to find my packed contracts in this folder. I say I expect my server to be on localhost 9080. So this is running against a live server. And then a little bit of boilerplate here. So let's bring that back in. And then if I go here, if I run my test, so you can see before I'd made my changes, it was running green. Oh. Oops. Let's refresh that. So there's my really quite lightweight test. And if I added more to my contract, if I could have a whole bunch of conditions in my contract and the test would still be that small. So it's quite nice. And so if I run that, it will run and it should fail. Cool. Yep, it fails. So it said we expected it to look like this and it looks like this. And so there's a problem. Your two services have a mismatch about their expectations. And so of course you can do that for two services. You can do it for a whole bunch of services. So just to, to sort of as a final point, I think one of the most important things when you're doing microservices is to have those consumer-driven contract tests. And that really will help you bake that quality in. And with that, I'll pause. And I think we've got a little bit of time for questions.
Okay, hello. So just a small technical issue. I hope it works now. Thank you, Holly. It was a really great presentation. I enjoyed it. And what I also like about it, especially in the beginning, I think the topics that you mentioned are not only questions for Java developers, but questions that every developer and basically questions that you have in every project. So that's quite nice. We do have some questions, so I would open our Q&A tool and pick some of them. So the first one is from Patrick. He's actually asking if you can give advice on where he can learn more about microservices for the Spring Cloud. If you can recommend some books or good courses, because he wants to learn that and he is not, or in his job they are not using any cloud services. So,
I mean, I think for Spring, the one thing I know of that's Spring specific is there's two well-established contract testing frameworks. One is Pact and one is Spring Contract. So if you're quite in the Spring ecosystem, it might be worth looking a lot more into Spring Contract. But beyond that, I'm not sure. So I'd be tempted to start with the Sam Newman books and those sort of more general microservices books, because the principles are going to be the same. Probably with the Spring ecosystem, there's going to be some libraries that may make it easier to test, like Spring Contract, that may also do some of the jobs of a service mesh, but I haven't used them, so I'm afraid I can't make any good recommendations.
Okay, if anyone else has a recommendation, please feel free to just put it in the Q&A tool, and then we can share it here again. Then the next question is a very philosophical one, I would say. It's how big is a small team? So Holly, what do you think? How big is a small team?
Yeah, I mean, because we talk a lot about the 2 pizza team and that, the microservices should be 2 pizzas, and there's various definitions, because I think it really has to do with the communication. So it will also depend on how good the communication is in your team. If your team has really bad communication, it may be 3 people is a small team, and anything more than that should be microservices. If you find, and it's about managing the communication overhead. So it's about things like, if I don't go to the stand-up for the team that, for this bit of work, do I have a lot of problems because now I can't keep up because I didn't go to their stand-up? So I find myself having to go to like 3 stand-ups, or we have one huge stand-up and that stand-up takes 45 minutes because each person talks for 3 minutes, and it's about, it will vary, but probably like 5 to 10 people is a good maximum size. And if your communication overhead is really high, that's a good point that you start to say, okay, we need to be partitioning this. I cannot care about what you're doing because it's costing me too much of my time to listen to your chatter about what you're doing. So you just give me an API. I'll write contract tests against your API. I'll talk to you once a week. That's good enough.
Okay, that's a good answer, I think. And it's like often in life, it depends. It just depends. Then... Another book, I haven't read it, but another book that a lot of people are recommending is Team Topologies. So that, again, that might give some sort of insights into the right team size and how you manage that. Perfect. Then there is another question from Patrick again. In your opinion, is the microservice approach good in all cases, or smaller apps are still good on monolith? And maybe connected to this question also from Mr. Anonymous, what's your take on self-contained services versus microservices?
So I think the first one is easy. I think microservices are definitely not the right approach in all cases. And I think we do sort of, as an industry, we tend to look at what the cool people are doing and we say, wow, they're so amazing, I want to do what they do. And we don't really step back to think whether it's appropriate for their context. But not every organization is a Netflix. And your organization will have different problems. It will have different requirements, and so some patterns have no downsides. Almost realistically, almost every pattern has a downside, and some patterns have quite big downsides. So microservices so I'd say, for example, automated testing has a few downsides, like it takes time, but it's got really big upside, so it's going to be appropriate for almost every team. Microservices have big upsides, but maybe not as big as automated testing, and the downsides are bigger. So you do need to make that call to say, am I going to take the hit for this without actually getting the benefits? The self-contained services, so I don't know if we can have sort of a back and forth, because that's not a term I've really come across. I'm not sure whether we mean like we're running in a single process, but we do have good modularity. And that's certainly something that I would absolutely advocate for. Like, even if you're not using microservices, you want that modularity, but you don't need to be distributed to have the modularity. And I think, or another sort of way of thinking of it is that I want each service that I do should have the smallest number of dependencies. And that is, that's a good thing to do as well. So one of the problems that we see with microservices sometimes is we're moving the complexity from the code to the network of connections between the code. So each service is tiny, but then you look at the sort of like the Twitter service diagram and the Netflix service diagram, and it's just like this massive lines, and you think, I don't want to debug that. I'm not sure that we've actually reduced complexity. We've just shifted it elsewhere. So having something that is self-contained, that a team can understand, and that has minimum dependencies, that that has a lot going for it as well.
Yeah, I would also say about the microservices, you had a good slide. You said like you don't do the microservices for the sake of doing microservices. So again, it depends if it helps and what's the bigger goal behind. So yeah.
What problem are we really trying to solve? Because not having microservices isn't a problem on its own.
Right, then then we have Django. It's not a question, but he says he was laughing out loud when you said the release board meets twice a year. He thinks he woke half the street. So Mr. Django or Mrs. Django, I hope you are in another time zone, because if yours half of the street is sleeping at this European time zone, then then we have maybe other problems. But yeah, I mean, it's also a tragedy, kind of. Holly, that were all the questions. Is there anything you want to share with us?
Don't think so, no, thank you. Thank you very much for all the really good questions.
Okay, thanks, Holly. It was a real pleasure to have you here, and I hope that you will join us again in the future. We will definitely invite you, so looking forward to that. Have a nice day, and we will move on with our program. So, dear developers, our next speaker will be Michael, and we will learn about the recent updates of Java 15 and how we can use it and how we can basically improve our work as Java developers. We will start in roughly 12 minutes at 3 p.m. sharp. So grab a coffee or a tea or whatever, and see you again in a couple of minutes.
you found your dream job as a developer? Or are you stuck in an unfulfilling job? On wearedevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now. found your dream job as a developer? Or are you stuck in an unfulfilling job? On wearedevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Welcome back. Thanks for joining. Thanks for staying here. I have here Michael with me. Michael is a Java expert for many, many years. He's an author, he's a professional speaker, and he will give us an update on Java 15 and what we can do with it and how it will improve our lives. So, Michael, thanks for joining. How are you?
Thank you to have the chance to give this presentation, this talk here. I'm fine, and yeah, I'm
ready to go?
Yeah, ready to go.
Perfect, then the stage is yours, Michael.
Thank you. Then I will share my screen. So, okay. So today's talk is about Java 15 and beyond, my favorite features. It's just a selection of things that I think you should be aware of. Let me briefly introduce myself. I was born a long time ago. Then I studied computer science in the northern of Germany. After that, I worked in various companies in various roles like senior software engineer, software architect, team lead, and CTO, and so on. And currently, I'm an independent consultant, author, and trainer. This is why I'm regularly speaking at conferences. This time first at We Are Developers. I'm glad to be here and to join. You see I'm writing a lot of books. Don't try to write books. You're getting, you will not lose weight. You will get fat, so don't do that. Okay, let's have a look at what happens to, or what is the contents of this presentation. I subdivided this into two parts. The first is the present. Here I will go through some important innovations which are coming up to Java 15 and which are included in some earlier versions. then I think it's interesting to have an outlook on what will happen in the near future, because Java 15 just arrived in last September, but Java 16 will come in March, and then after that Java 17 will emerge in September, and it's planned as the next long-term support release. So perhaps nice to know what we should expect. So for the first part, what is the contents of the first part? We will look at several improvements in the syntax. First, we will have a look at switch. Switch is old and a bit, clumsy, and we will see how elegant solutions can get right now. Then every Java developers know these null pointer exceptions, and the messages get more informative right now if you use special parameterization. Then having the possibility to write multiple lines of text in one string, known as text blocks, is the new feature. It's really nice. And then two nice things which are right now in preview. These are records. They allow us to define small classes, immutable classes, and just a few lines of code. We will see that they are very nice and handy. And using instance of is sometimes a bit cumbersome, but it gets improved and will be improved in the future. So let's go through these. First of all, just an overview of what was included in Java 15. We see a lot of things, but the green ones we are going through. As I mentioned, some of them are developed earlier, or released earlier. Switch expressions and null pointer exception, they are included in Java 14, but also, of course, in Java 15. So let's go through these enhancements. When we look back in the early days of Java, when I'm a young developer and I started with C++, and the Java was a newcomer at these days, not a language like it is today. And what Sun at that time wanted is to make it more convenient to come from C++ to Java. So there are some compromises in the language design. So they stuck to the old switch case, and we have these break and fall through all these things, which can easily be misunderstood. And we all know that there are error prone and that we can make mistakes, and we will see this with examples in a few seconds. And of course, you're a bit limited how to specify values. And it was really time that we see an improvement in switch, and let's look back why. So just a simple mapping of weekdays to their lengths, and we have these weekdays, we have then all these cases. You see, we have to write them below each other. We need these breaks. If we leave it out, we will see this. Then we have a fall through, which may be intended, but often it's not intended. It's not that bad, but it's not so precise. It's not that elegant. So what about this? If you use Java 15, you can use this switch case, which allows you to have a comma separated list of values. Then you have this arrow, what you know from Lambda expressions, and then you can have this assignment. It's a lot shorter, it's a lot clearer. And what you see, you don't see a break here, and that's good, because there's no fall through. So you will not execute code you not wanted to execute. But it's even better. You can get rid of this variable. You just can return a value from the switch, and then you can write it down in a very short, concise way. I really love how they modified the syntax. It's very short, elegant, and nice. And even better, it avoids all these pitfalls. And let's look back these pitfalls in this old switch. We see here a not complete implementation of a mapping from months to its name. And we see, okay, only the cases January, February, March, and July are covered. And there's a default in between. And the default in the middle of all these cases is in the old thing bad, because you often don't see this. And what you see here again is you have a hidden fall through. If you have something what is not January, March, July, then you are getting to the default. Your mapping is not available, but then you have this fall through, and then you this results in February. So this is not what you expect, and it's so easy to make mistakes. And if someone is adding new cases and he's adding them at the wrong position, then it's getting confusing. So again, it's a lot clearer with Java 15. We are able, because we can return a value, we can just write return switch. We can put on all our cases, and we can even mix the cases in the default. Because there's no fall through, we don't have the problem. We get the correct mapping. If we have April, we get this not available. Still, it is feasible to do the default as the last, but it has no negative impact besides readability, but not concerning program stability. Another thing is, if you have something like this code, sometimes you like to have a special handling of one of the cases. This is possible. You can say, okay, for Monday, Friday, Sunday, I want to do a special handling for Sundays and print out Sunday as fun day. But then you have the problem how to return this value. So there's a new keyword which is called yield, and then you write it as follows. Then we are coming to the null pointer exceptions. Nearly every Java programmer knows null pointer exceptions, and normally they are nothing good. So how do they happen? Yeah, it's of course not always that easy as in this code snippet. You have a variable a, and this is assigned null, and you are accessing something like the value, and of course you get the null pointer exception. But even there, this message is not that informative, because you have to match this line number with this line number in the source code. If you switch on this show code details and exception messages, then let me move this a bit. Then you see that we get a much nicer message: cannot assign field value because A is null. This is very informative. You really get to know what goes wrong. And of course, source code is not always that easy. Source code is like this, or like that, or even in practice is even more complicated. What do we have here? We have a string array which is initialized with null values. Not a good idea, but a good idea to show the new feature. So what are we doing here? We are accessing this index 2, which is of course a null, and then we call last index of. And then we see, okay, last index of can't be called because string array at position 2 is null. Or if we want to add a 3 to a null value, then we see, oh, this gets problems doing unboxing. And then we see, value is null, this is not working. And this which may be helpful when you are in a testing, debugging phase, and you are not able to catch the error otherwise. Okay, let's move over to text blocks. A fantastic feature, very nice. We waited so long for multi-line strings. If we don't have multi-line strings, as we see this in the example below, and we want to include multi-line of text, then we have to add all these line separators, and it is so annoying to have all these escape sequences. And if you look at this, or if you imagine this is a bit longer and a bit more complex, then it's getting hard to read. So why don't write it as you like to write it? Just this multi-line text and no escaping, no line breaks. What you need are these three, was heißt denn nochmal Anführungszeichen? You have these three, do you know Anführungszeichen, someone? Sorry, I have a small blackout, but what you see, you don't need this escaping, and you can even use the backslash, and it's very easy. If you look at HTML code, you see you can see the indentation. You don't need these line breaks. It is very easy to use, and you can even have placeholders there, and then put in values from an object array. And the best is if you have to process JSON data, you're able to fill in all your JSON just as you know it. You just write your JSON document, and that's a pretty cool new feature of Java. So the next one is records. Records, it's a nice, cool feature. And do you remember if you want to write these data transfer objects, or you have to define all your data transfer objects if you're going from one level of your application to another, and one tier to another, and always you have to define data transfer objects, and you have to write all these getters and setters. Wouldn't it be nice and cool to just write what is necessary, what is really needed? And this is possible. We have this enhancement. This is called record, and what you just write is record. You put in some parameters which are referring the attributes, and that's all. And we will see what what you can expect on the hood. They define just a simple class having two data members, X and Y, and it's very compact. And the interesting thing, if you know that these attributes, these variables will not change, then you are able to generate a class with access methods. You can derive equals and hash code, and they are adhering to the contract, which is not that easy if you write all this on your own. And if you have set methods, then it's getting even harder to do this consistently. So let's have a look at an example. You have this point, you have two coordinates, you have these SX methods, but what's happening on the hood? There's this tool built into Java, it's called JavaP, which shows you the bytecode of a class or a record. So if you do this, you see that this is compiled into a class which extends Java lang record, which has a constructor, which has these methods, which has toString, hashcode, and equals. If you want to achieve the same thing shown here on your own, you have to write something like this. You have to define a class, to define finer attributes, a constructor, an equals method, which is doing all the necessary checks, a hash code, and a toString. And of course, these two methods accessing the variables. But what you see is this is a lot of code, and I know a lot of DTOs which do not have an equals or do not have a hash code method, and this always causes problems later on. So the cool thing is that you can use these in combination. You can define other records on base of your already defined records. You can also define special constructors in these records. This is pretty cool and pretty straightforward. The good thing is you can easily use records as return types. A lot of times in practice, you need something like a return code and an additional information, or you have a code and you have a list of values. And if you want to return this is not that easy in Java. You can write your own pair classes or your own classes, but it's a lot easier to just write a record. And then you can use this to return multiple values. Another idea is whenever you have a map, sometimes you need something like a compound key. You have something like a name and an age, and these both are the key. And of course, again, you can use a record to define something like a compound key. So to get a better understanding, so a lot of times you see, or sometimes you see definitions of pairs like this. You have two variables of type T, you have this constructor, and perhaps you have this toString. What's wrong about this self-made pair? If you are in a very, very local scope and you know that you will just use it as a return value, perhaps it's okay. But we don't have an equals and we don't have a hash code. If we use this in a collection, we want to search for it, or we use this in a hash map, then we get problems. So using record again saves your day. And you see, you can use it even for primitive types. That's nice. You can mix reference and primitive types, and you can even use generics. So imagine you want to return your top 3 favorite pizzas. Then you can create something like top 3 favorites. to summarize, it's really short, it's really clear, it's very, very useful for all these situations where you have to define something like pairs, tuples, and yeah, the cool thing is that equals and hash code are automatically generated and that they're correct. So, but if we see this, if we want to use it, there may be special cases, and something what I haven't showed right now is checking for validity. So what do I mean? Imagine you have something like a closed interval, which is a mask something which has a lower and an upper bound. So if you define something like this, it's desirable that lower is not higher than upper. So you can write this down, you can have this check, you can have an error message, and then you can have this assignment. This is okay, but we have these nice record just having these two attributes, and this is a little too much code to write, and this is why there's a shortcut. It's a kind of magic. I'm going back. What is removed is you don't have to put in the arguments in the constructor, and you don't have to do the assignments, and you see you have a very short variant of this definition, and you just have to know what you really want to express. So you have a closed interval, you have this check for lower should not be bigger than upper, and that's all. And it's equivalent to this, but much nicer. So the last question, can we combine all these cool features? And the answer is yes. We can have something like a record multi-types, which has a lot of types, defining a map and an additional info. We can even have own methods in our records. And we can do strange things, but funny for this presentation. We have a list with restriction, which is size restricted. We can say we have the values and we have a max size. And if the size of the values is bigger than this max size, we can say too many entries. And yeah, that's pretty cool. I love records. I think it's very, very cool feature. Then move over to pattern matching and instance of. So if we look back to the code that we have to write or that we sometimes see, we have instance of checks. So we have, of course, this is just an artificial example, so you directly see that this object is of type person, but normally perhaps you get this from a method call. So then you have perhaps multiple instance of checks. And what you know as a programmer that in this situation, this is of course a person, and I want to use it as a person, and then I always have to write this nasty cast. But this is needed because of the syntax of Java. But wouldn't it be nicer to write it like this? If object instance of person, we can hand over a local variable. And of course, we can access everything from type person here. I think it's a lot more readable and it's pretty nice. Let's see. Again, we have a string. Of course, we can ask for the string length. And in the else, of course, there is no string variable because it is not of type string. And even a bit advanced things are possible. You can ask, for instance, of let's say str2, and you can ask for the length. So you can even combine conditions. One word of warning, this is nice for simple instance of checks. So, but instance of checks are in general a sign that there may be a design problem. So please first check if you have a design problem and if you can get rid of your instance ofs using inheritance and polymorphism. This is always nicer, but if you have this situation where this instance of is handy, then use a new syntax and you can get rid of the casts. Another thing, the last thing for Java 15, which seems to be a bad thing in my opinion, but which may be a good thing, is Java included a JavaScript engine, which is named Nashorn. It was deprecated a long time ago in Java 11, and it's now getting removed. The argument is, or this is due to the fact that JavaScript is moving forward and there are a lot of newer versions and features, and they are not supported, and it's not that easy to support all the newer versions. That's correct. For me, the support for JavaScript is not that I have to use the latest JavaScript things, but to execute calculations on the fly, to be able to do dynamic calculations. And this is something I can't do without this JavaScript engine, but I want to show something else as a remedy. JShell. So perhaps people who know talks of mine where I talked about the shell, I don't like in the past, I don't like the JShell because it was not comfortable. But right now it's getting better and better and better, and it is useful for a lot of things since Java 14 and Java 15. Before, it was horrible to edit. I will do a very brief or short demonstration in a few seconds. What is possible? You can define methods, you can import things, you can create methods, so you can get used to APIs. So let me show. As you see, I've just installed Java 16. What you can do is like defining a method add, and that's my normal example. And I'm doing some typos. Just to show. With the new JShell, you get error messages, and you have an editor which allows you to go through these lines. And okay, I missed this type, I missed this one, and I missed this R. And now we have this method. And this is extremely helpful. Without this multi-line editing, which was added in Java 14 or 15. JShell is not quite user-friendly, but I really like this right now for small experiments. So we had this demonstration. Oh, sorry. That's wrong. Yeah, this short demonstration. What we see, we can perform calculations on the fly. And it's getting cooler and cooler with the newer Java versions. and it's even possible to include third-party libraries if you want to, but normally I use it like I showed, but the pretty cool feature is that you can call it with the command line parameters enable preview, which enables preview features like we saw some of them. And this is good to do your first experiments while the IDEs are not able to handle these new syntax things. What can you do with this JShell? You can even programmatically create a JShell instance, and you can call eval to evaluate things. And then you get something like snippet events, and then you can ask for snippets values and the variable value. It's a bit clumsy, but it's okay to use. So what you can see is I can even use var here, and var is translated automatically into the correct type. And this is the starting point when you want to do calculations. If you imagine you have something like plotting mathematical function, and the user is able to just input this function, then this is hard to implement in Java, but it's easy if you can call something like eval. So we talked nearly half an hour about the features of Java 15 and my favorites. Now let's have a look at Java 16 and the future of Java especially. First, congratulations to Java. It's 25th birthday. As I said, it has a long history, and I started around 1969 or 1968 to use it professionally. It was an absolute newcomer and the new kid on the block, but yeah, it's now well established. We see a lot of things, generics, lambda streams, and a lot of changes, and they are very, very important to modernize the language. When we look at the TOB index, we see that in the past, C is dominating the popularity of the languages, and yeah, Java came in and gets popular and most popular language a lot of years, and now yeah, C is most popular, but what you see is Python is getting popular too. So what we should ask is where to go from here, and what we have to adjust in Java to win the race against the competitors. So if we look at another chart, we see that black is Java. So Java is nearly always the most important language, but yeah, C is sometimes popular. But in the last few months, the popularity of Java drops, and you see the trend, which is not going up, but it's going a bit down. So, but what you see is Python is coming and increasing, and I'm using Python for my playground projects, my personal projects. Sometimes I'm programming in Java most of the time, but I really like Python because it has some very nice features which are missing in Java. So what I wanted to show is there are other languages which are becoming popular, and we need the evolution, and we need these new features in the syntax and in the APIs, because the other languages are popular, and they are popular because they have modern language features. If we compare these both competitors, C and Python, in my opinion, Python is very has more impact than C. C will perhaps always be a popular language, but more for hardware-oriented programmers, and but Python grows, and we have, or Java can learn something. What we took over is Python has something like tuples, to define tuples. This is built in. That's very easy to use. We now have something like records. So I think records are perhaps a bit better because they're type safe, by the way. And one very strong point to get started is the read eval print loop in Python, which we now have adequately with JShell. And there are interesting other concepts like list comprehensions, which we don't have in Java. So, but perhaps we will see something like this. If you look at Java, it looks a bit clumsy, it looks a bit expressive, but we saw switch expressions, we saw records, we saw text blocks, which bring elegance back to programming with Java. So what are the plans for the future versions of Java? If we look just for the Java enhancement proposals for the next version of Java, Java 16, we see a lot of things. A lot of things are irrelevant for the normal Java developer, but there are some which are perhaps interesting. This is packaging tool, which allows us to create executables. This is interesting. I played around with it a bit. So you can create executables for your Java versions, which allows to distribute without JDK. Then pattern matching with instance of gets not a preview, but a final feature. The same is true for records. And then we have something like seal classes, which allows us to control inheritance, which is not that often needed for the normal programmer, but for frameworks. So what we can see in the Java community, or in what is going on in Oracle, we have 4 projects named Ember, Valhalla, Loom, and Panama. In Ember, we have something like the things we switch and other things to get a better, to meet better the expectations of the modern programming language. Then Valhalla is a bit more specific to modern hardware, but interestingly, there are something like value types that are types without identity. So, and the other one is perhaps generics for primitive types, which is the desired feature for a long time. And the last one that I want to mention is Project Loom. Of course, performance is always a topic, but interestingly, an alternative to threads should be supported. They are called fibers. And in the days of high throughput and distributed applications, perhaps this is an important step to make concurrency easier with Java. So what are the plans, or what are hard decisions for Oracle in my point of view? If you look at Java 16, you see, yeah, not all of these are already included, and in the next few months we will not see them. So I personally, I'm not convinced that Java 17 will get the next long-term support release, because a lot of things are missing. So what can happen is that this long-term support release is shifted to Java 19, which is, in my opinion, a good, or would be a good choice, but these are just estimations. If we do this and we publish Java 17 as a long-term support release, a lot of people are perhaps not as satisfied with the progress and the contained features, and we have to wait another 3 years for the next release. So that's why my guess is that we will see Java 19 as the long-term support release. But let's look what the future will bring. So let me conclude. Positive things, Java is moving forward and gets more modern and gets more attractive. We have a lot of positive things in the syntax. We have switch, we have records, a lot of tons of nice things in the APIs. Then we have to mention JShell right now. For scripting and for beginners, it's interesting. For the professional Java developer as an alternative as for the IDE, no. There you use the IDE, and we get a new HTTP2 API, which I not covered here, but I want to mention because it's so nice to work with it. Then what are the negative things? We saw a lot of delays for Java 9, and this is why Oracle switched to this half-year release cycle. And again, yeah, the next releases were right on time, but just Java 14 brought a lot of new syntax features, and yeah, you have to think about is it worse that Java 17 will become the next LTS? And again, we see that some things are missing. We have no versioning for this project Jigsaw, also known as modernization. We have no JSON support. They said they will include this. Yeah, and we have a lot of other special things which are not that good, but the positive side things are, of course, the more important, and Java is getting nicer and nicer, and you should keep this in mind. And I think Java is ready for the future, but it has to be ready for the future to be that popular in a few years again. So that's it from my side. I'm right on time, 45 minutes. So do you have any questions?
Hi, Michael. Thank you so much for our presentation. There are some questions.
Yeah.
We will get them right into the screen. And yeah, you're really on point, exactly 45 minutes. That's cool. So let's move to the questions. So there is one about what changes in library and calls we have now in Java 15. What about concurrency and synchronous ones?
Yeah, in Java 15, there are not that much of changes, but in the older versions, you see the Flow API and you see Completable Future, and you really should have a look at Completable Future. It's a fantastic class to ease your concurrent programming skills and abilities. I wanted to include this to this presentation, but it was introduced in Java 8 and then modified in Java 9 or extended in Java 9. So I'm not including it into the presentation for Java 15.
Okay, thank you very much, and thanks Candida for the question. Next question from Erfan. He is asking, will Java Lambda feature will still be valid in the upcoming Java releases? Are there any plans for change?
Yes, there are. It will be valid. I think lambdas are a very important feature. You have a lot of use cases. They are very useful in the Stream or in combination with the Stream API. They are removing the underline as identifier in Java 9. This is planned to mark unused parameters in Lambda expressions for the future. So this may come in Java 17, but I don't know. But yes, of course, lambdas will, or functional programming will be supported. It's very important.
Okay, thanks Erfan for the question. Then Avais, thanks for the next question. It is good. It's basically, Michael, your opinion about Kotlin, and will it challenge Java at some point? Will it take over?
Yeah, good question. As I presented in the TIOBE index, it's not that popular. I know Java developers like Kotlin, and I think it's a good alternative, but perhaps it's a good extension. I don't see it right now as an alternative, but as an extension. What I think is that Python may be a competitor, but we will see. In the next few years, we will see that perhaps Python or Kotlin are becoming more popular, but I think it's important that Java moves on with this, getting easier syntax and more improvements to avoid that Kotlin and others will be better.
Okay, and Mr. Anonymous is asking about Scala. If you want to say something about that.
Yeah, I think Scala as well as Groovy had their hypes a few years ago. So personally, I'm not so I'm not the Scala guy. I worked a lot with Groovy, but this was perhaps 5-7 years ago, and I don't see them, or not. They are not so popular right now. So I'm not quite sure. I think then Kotlin is perhaps more relevant.
Yeah. And Sebi is asking if it's worth migrating a big project from Java 8 to Java 15, or would it maybe be better to wait for the next LTS?
Yeah, I think it's worth migrating to Java 11 because you get a lot of new features, you get a lot of new possibilities, and then you will move from LTS to LTS. This is perhaps the preferred way. If you have your simple playfield project, then of course I'm using always the latest Java versions for this. But for professional projects, my opinion is to use these long-term supports.
Okay, I think that's a good answer, and thanks Sebi for the questions. And then there is a last question from Patrick, and he is asking about advice for a person that just started the developer career and wants to work with web apps, Spring with Java or Kotlin, or maybe we'll switch to .NET Core for web apps. What's your take? What would you advise, Patrick?
Okay, it's if you start doing web apps, it's important if you say server side or client side. Client side, perhaps please don't do JavaScript, do TypeScript. It's much nicer. But on the server side, yeah, if you want to start with Spring, of course, that's cool, but it has, it's not that easy to learn, but for your professional career, it should be a good choice. Spring is always a good idea.
Okay, perfect. So, as time is ending, I would like to say thank you very much, Michael, for joining our We Are Developers Java Day. We are moving on with a very short break and we'll be back in a couple of minutes at sharp 4 p.m. with our last talk of the day. So again, Michael, thank you very much. And to everyone else, grab a coffee and see you in a couple of minutes.
Many thanks. Bye-bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On wearedevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Okay, welcome back to our last talk for this Java Day today. I have here Daniel with me. Daniel will talk about Java and the closure mindset. I'm very much looking forward to this presentation, to this talk. So Daniel, how are you today?
Fine, thank you. Good.
Perfect. Are you ready?
I'm ready.
Perfect. And then the stage is yours.
Okay, let me
Bye.
share my screen. Thank you very much. So let's see. So thanks everybody for coming. As I said, my name is Dan. I work for Actful, and we are here today to talk about Java, but this time around with a closure mindset. And I want to start the presentation with a little quiz. Who can tell me what this is? So this is basically how closure looks like the very first time that you see it. And I want to point three important things in this picture. The first one is that's very ugly. Some people will say that it's even disgusting. The second thing is that there are a lot of things in that picture that make no sense at all. For example, why would you want to keep a bug in your mouth? And what the hell is that? And what is doing there? But third and most important is that this picture is alien. So when we are looking at it, we are making a judgment from our human point of view, from our Java perspective. So maybe we are not being fair. And maybe with a little bit of time and the help of the Hypnotoad, these three aliens probably can look more like these other three. Because with understanding, it will come a change in perspective that will allow us to make a fair judgment. And I know what you're thinking, right? Wonder Woman is not technically an alien. And if we are talking about closure, probably the picture should have a bunch of parentheses on it. But still, if we spend some time learning about these aliens, maybe we'll find some superpower that we can use on our day-to-day job as Java developers. For those that are not familiar with Closure, Closure is a functional, hosted, dynamic, strongly typed Lisp for the JVM. So what we are going to do in this session is using a real-world application as an example, see how each of these aspects of Closure affected the way that we built and affected the way that we designed this Java application. For a little bit more context, when I got involved in this particular project, I have been a Java developer for around 13 years, and I have been messing around with Closure for around 2 or 3 years. So I consider myself to be in WCOS stage 2 on my transformation to a full-blown alien. So because we're going to talk about a real application, this is the application that we are going to talk about. It's one of these betting one of these bonus applications that you see in some betting industries. One of those that they tell you that if you make a deposit now, you will get double the amount cash for free, or if you sign up right now for an account, you will get £1,000 cash free. Obviously, nobody's going to give you anything for free. So if you read the terms and conditions, to be able to withdraw that money, to be able to get that cash, that free cash, and put it in your pocket, usually you have to perform a series of actions in the platform. Also, in our particular case, and I don't know if this is common, to be able to get that bonus, be able to withdraw that cash, we also have a limited amount of time to perform those actions. So removing all the marketing fluff, this is what the system that we had to build, what it had to do. Yeah. So put some money into the user's account if he has done loads and loads of bets, and if he had done it within time limit. Yeah? So from an implementation point of view, what our application has to do needs to know which bonus are available, which client has signed up for which bonus, and then it needs to keep track of which actions that client had done over that week of time. Yeah. So let's see, the difference between Java and Clojure. Clojure is a functional language, while Java it's an object-oriented language. From all the principles, practices, and concepts that are usually associated with functional programming, I want to focus on just one that in my personal experience had made the biggest impact on how I build systems and how I design solutions. And I think it's especially important because it's easy to translate to any programming language. And this is the concept of a pure function. Pure functions are pieces of code that for a given input, they always return the same output. Always, same input, same output. And why are pure functions so important? Pure functions have several benefits, but the key one from my point of view is that they are easier to understand. Because to understand that piece of code, the only thing that you need, the only context that you need to keep in your mind, it's those input parameters. Yeah? Pure functions are a little bit like physics laws. Once you understand how a pure function works, you can rely on it working exactly the same every single time. Yeah? And because pure functions are easier to understand, it also means that they are easier to change. And change is what we developers do for a living. It's very, very rare that you start a new piece of code that is completely isolated from any system. And even if you created a new project like 15 minutes ago, you are already in the business of making changes. Now we're talking about pure functions, we have to talk about its evil twin, side effects. Side effects are all those things that really makes your application hard to understand. Because suddenly to understand a piece of code is not just enough to look at the input parameters of that function or that method. You also have to think about all the dependencies that the code has and the dependencies on the dependencies. And you have to think about all the possible states on your database and all the possible states on the network. And you also have to think about what can multiple threads be doing at the same time on that particular piece of code. So the context that you need to keep in your head is really, really big. And once you have side effects in your code, you don't really, and you're not sure what's going to happen the next time that you make a change. And these kind of side effects, happens to us all the time. You make a small change in one part of the application and suddenly something completely unrelated breaks. So one of the key things that I have learned on my journey to become a functional programmer is that side effects are the enemy. And a big chunk of functional programming, it's about fighting these side effects. There are basically two types of side effects. Those that change the state of your application. And then we have input-output side effects. Yeah? The input side effects are called co-effects, and the output side effects are called effects. Now, what we are going to do is look what we can do to fight with each of these effects. Yeah? So we'll start with the state. As I mentioned, for our application, we need to know which client has signed up for which bonus are available, and then we need to keep track of the actions that client had done on the system. Yeah, to do this, imagine that we keep a hash map where the key is the client ID, and then the value is some kind of client bonus object that contains a reference to the client and the bonus. And then because we want to keep track of all the deposits that the user had made, we'll have some kind of deposit list with a bunch of deposits on it. And then we'll have a bet list with a bunch of bets, with a bunch of bets. Yeah? So this will be our object graph, our domain model. Yeah? And we'll have one of those for each and every client. Now, when it comes to state management, what I will have traditionally done is make each and every object responsible of its own state, of managing its own state, which means that basically that hash map will have a little like machinery that will make sure that the several threads go through it or try to modify it or read and modify it. At the same time, they will see a consistent state. And I will do the same with client bonus. I will put there some little machinery to ensure that multiple threads see a consistent state. And I will do basically this with each and every object. Now, if you think about it from a complexity point of view, what does it mean each of these little machines that we have there? Whenever you go and change a class, a code from any of these classes, it means that you have to keep in mind not just the business logic that you need to implement, you also have to think about all the possible, not side effects, concurrency issues that your code has. So you are mixing in the same place, in the same piece of code, business logic and state management. So what Clojure teaches is that to simplify your code, to simplify the code base, what you want to do is separate those two aspects. On one hand, you want to write your business logic, and on the other hand, you want to deal with state management. So how you go about this? The first thing that you do is you make everything immutable. Even if that hash map containing all the client bonuses, everything is immutable. Now that everything is immutable, you can write your business logic very easily because you don't need to think about what other threads can be doing on that object graph at the same time. For the state management, Clojure comes with a construct or a class called an atom. And you can think about an atom basically the same as a Java util atomic reference, but with a little bit more functionality on top of it. I'm going to try to explain how, if you're not familiar with atomic reference, how an atom or atomic reference work. So we have the atom that has the little machinery to do state management. And then that atom points to our immutable, and our immutable graph. And then you as a developer, the only thing that you need to do to build your business logic is to write a pure function that accepts that immutable state as an input parameter, and then it generates the next state of your application. To try to understand this thing a little bit better, what I'm going to do is I'm going to explain what happens if two threads at the same time try to change the state of our application. As I said, both threads start with the current state that is contained within the atom, and they start calculating the next state of the application. Let's say that thread number 1 finishes, and it creates that green state. Now, thread number 1, once it finishes, it will go to the atom. I will ask atom to change the state to the green state. And what it does, it compares that the current state of the atom is still the same state, the same white state that it used to calculate the green state. So in this case, because the current state of the atom is still the white state, it means that the atom will move to the next state, that is that green state. Now, thread number 2 has finished, and it calculates that blue state. Now, when thread number 2 goes and tries to change the current state of the atom, it will notice that the state that he used to calculate the blue state, it's no longer valid. It's the green state. So what thread number 2 has to do is to start from scratch. So we'll have to, again, start calculating what's the next state, but this time around based on the current state of the atom. Now, and this will move. Now, you as a developer, you don't need to worry about all these. These are basically a compare and swap operation. You don't need to do any of this conflict detection or any of the retries or anything. All that machinery is provided by the atom. So you as a developer, the only thing that you need to do is create a pure function that moves you from current state to the next state. To emphasize a little bit of what does really this thing means, I want to point out 2 things. The first thing is that on the life of the application, the only valid states were the white state, the green state, and the red state. Nobody ever saw that blue state, right? That blue state, it didn't exist. The second important thing is that if there is another thread that at the beginning of time, it reads the current state of the atom, and it gets a reference to that white state, as the atom moves from one state to the next, that thread number 3 will still point to the original state. Because it's immutable, nobody can change it, which means that thread number 3 can be working with stale values. Now, some of you maybe wonder, well, if I have to get a copy, I create a new copy of all these objects every time that I want to make any change on the state, probably this immutability thing is very, very expensive, right? Now, it's actually more expensive than doing mutating in place, but not as much as you will expect. Let's say that to calculate that green state, the only changes that we need to do is to change that bet object there on the bottom right. Now, because that bet state is actually contained into the list, it means that we actually need to create a new list. Because that list is contained into the bonus client, it means that we need to create that bonus client. And because that bonus client is contained within that bucket on the hash map, it means that we need to recreate that bucket. Now, these 4 objects are actually the only difference between the green state and the white state. So to create the green state, we actually just need to create 4 objects. We don't need to copy everything. We just need to create new 4 objects. And all the other objects, we can reuse them because they're immutable. So when we know that sharing immutable objects is perfectly fine. Okay, this is what in functional programming, this is a technical structural sharing. Now, as I said, it's a little bit slower, but you get some benefits because when you go and you want to ask this question about this thread safe, the question becomes easier because you don't need to think about the Java memory model and you don't need to think about the happens before semantics. To know if a piece of code using atoms and immutability is thread safe, you have to take into account these 3 rules. The first one is that the state is always consistent. As we saw with that blue state that never exists. So you don't need to think too much. It's just that the state is always in a consistent state. The second rule is that the function that you use to calculate the next state must be a pure function. As we saw with thread number 2, it's possible that the atom machinery it will retry the function. So you need to make sure that that function it's a pure function. The third rule is that anything that happens outside that atom machinery, you still have the possibility that you are subject to race conditions. Okay, so this is a lot simpler than Java memory model and the happens before semantics. So let's see how this affected our Java code. Yeah? The first obvious thing is that we made all of our domain object all was immutable, including those list of deposits or the list of bets, everything was immutable. The second thing is that for that state management, we actually did not make the whole object graph one immutable value, because what one client did in one bonus campaign did not affect what other clients did in the same or in a different bonus campaign. So what the application logic actually need to see as in a consistent state what each of the client bonuses. So what we did, it's like create one little machinery for each of those client bonuses to do that atom-like semantics that I mentioned. Now, we didn't write any of this code because all of this is provided by the compute family of methods that comes with a concurrent hash map. Yeah, each of those compute, it basically gives you an atom-like semantics, but it gives you on a per key basis. So putting both things together, this is basically how our code so far will look like. We'll have a concurrent hash map with our state, and then we'll calculate the next state in an atomic way. So for example, here we get a bet, and then using that compute if present method, we'll calculate the next state. And as you can see there, we decided that it was the client bonus itself, domain object, the one that will know how to calculate the next state. And I just want to reinforce that that's immutable, which means that it will create a new client bonus. It's not that it will modify itself, it will create a new client bonus. So this is basically how you deal with state in a more functional way. To separate your business logic, your pure business logic from your state manager. So let's see what we can do about effects. Effects are those things that your application need to do to the external world to basically change the state of the external world. In our case, it will be things like notifying about the client about the progress in the bonus campaign, or paying the price into the client's account. So what I will traditionally done is to write one of these services classes that you get, you inject a bunch of dependencies, DAOs and other services, and that class, what it does is it does that orchestration, right, between different parts of the application. Now, if you think about that kind of code I usually put on that service class, it's actually doing two things in the same place. On one hand, it's deciding which side effects, which effects need to produce. And on the other side is executing those effects. Yeah? So in the same place, you are mixing two things, deciding what needs to happen and making that thing happen. So following a functional or closure style functional programming, what you want to do is separate those two concerns. So how we did that? So what we did is in that pure function that calculate the next state of the application, instead of just calculating the next state of the application, we also decide what effects need to be executed. Yeah, and here we're just deciding what needs to be executed. It doesn't run anything. It just decides like to change from this state to the next state. You need to also execute these actions, these effects. Yeah, this means that first thing that it means that your effects become, first-class citizens. You need to create a class to be able to talk about them. You need to create a class to talk about them. Now, this is just representing that, okay, we need to make this effect, but all the things that you can make as part of a pure function, you can also decide, for example, how any kind of error that happens while executing that effect, how it should be handled. And you will do that by wrapping that effect into some kind of policy, for example, an ignore error policy, while other times maybe you want to stop the JVM. Yeah? So in our pure function, the one calculates the state. Not only you decide which effects need to be executed, but we are also deciding how the errors on those states, on those effects should be handled. And also, the other thing that you can decide there on your pure function, it's decide how those effects should actually be executed. So in some cases, you maybe decide that the effects should be executed in a sequential way. Yeah, so if effect number 1 doesn't run or fails for some reason, it means that you don't want to run effect 2 and effect 3. While other times you know that the effects are completely independent. So one error in one should not affect an error in another. So for our particular bonus application, what we decide to do, instead of building all this flexibility into that effect system, we decided to do something a lot simpler because the number of effects that we had, there were not that many. So we decided to encode in the Java type system what were the valid change of effects that you could build as part of your business logic. Now, if we put, now we have just decided what need to be executed, we still need to run those effects. So in our particular case, we decide that it will be the effect itself, the one that will know how to run it. Yeah? To be able to run itself, it needs some dependencies. And here we are talking about things like JDBC connections, GMS clients, or HTTP clients, all those dependencies to be able to produce those effects. Now, creating an interface like this, it will mean that it was very easy to find which parts of the code base will have side effects, because to be able to execute any side effect, you will need to see that dependency as in your method. Now it has the drawback that you sometimes have to pass these side effects, this all dependencies object all over the place, which was a little bit cumbersome sometimes. And also that all dependencies actually contains all dependencies of all the possible effects that any of the possible effects could do, which means that it became like a Spring context with a lot of things there. It was a little bit messy. Yep. Now putting these two things together, state management and effects, this is how our code will look like. We have that stakeholder that calculates the next state and the effects to be executed, and then we just tell the effects to run themselves. Now, this is the question. Is this thread safe? Well, if you remember the 3 rules, probably you don't remember, but the third rule says that anything that happens outside the Atom machinery is still subject to possible race conditions. And where is here the race condition? They say that we have 2 threads that at the same time, they run that next state, and they calculate the next state and the effects to be executed. And they run it basically in that order, right? First thread number 1, and then thread number 2. Now it's possible the thread number 2 gets to execute their effects before thread number 1. And this can be okay, or it can be not okay, depending on your business logic. If it's not okay for your business logic, Clojure comes with a construct called an agent. And you can think about an agent like an atom, but it's a single threaded atom. So any actions or any code that goes through that atom, it's sequential. So you avoid that possible concurrency issue. And if you are familiar with Erlang or Scala actors, then threading model is something similar. Now for our application, for the bonus, it was actually not acceptable that these race conditions will happen, but still we decided to use atoms instead of use something like agent. And why was that? It was because we were planning to run this bonus system in several instances at the same time. And because we are running now in several instances, it means that now we are under the realm of distributed system programming. Now, because our effects, we could not do them in an atomic way. And the distributed system theory tells you that you have to choose between running them at most once or at least once. Yeah? So you either are happy for your effects to happen 1 times, or you're okay if they happen multiple times. So what we did is look in our code base for all the effects that we had. And for each of them, we decided if we wanted at most 1 semantics or at least 1 semantics. For the ones that we decide that we want at least 1 semantic, we did nothing. We didn't need to do any coordination. But for those that we wanted at most 1 semantics, like for example, paying, what we did is just an coordination mechanism outside our code, outside our code base. Yeah? In our case, we decided to use just a regular database because it provides the guarantees that we need, that is that atomic, consistent, isolated, and durable way. So what will happen is that all 3 instances decide to pay the same bonus to the same client at the same time. They will all 3 go to the database, and the database will make sure that only one of them will actually get the green light to go ahead. Now, I want to point out that it was still our pure business logic, the one that will decide which kind of semantics we wanted, if we wanted at most 1 or at least 1. And we'll do that again, similar with the error handling, we'll wrap the effects in some kind of policy. Okay. So let's talk now about coeffects. Coeffects are all the inputs that you need in your business logic to make the decision. In our case, it was which client has signed up for which bonus and all the actions that client has done on the platform, and also what time it was. That was, we needed to expire, so we also needed to know what time it was. So in our particular case, as I hinted before, we were actually keeping all the state of the application in memory, and we were able to do that because we were using Kafka as our input source. If you are not familiar with Kafka, you can think about Kafka as a messaging queue, but that is able to remember all the messages that have gone through it. So what we'll do is when the application started, we'll go to Kafka and we'll ask Kafka for the last 3 months of messages that have gone through it. And then we'll build the state of the application based on that those historical records. Yeah? For the time, to know what time it was, instead of using the system clock, what we will do is, because each event will be timestamped, we will be using the timestamp of the event as the current time of the system. And if you are familiar, this is basically event sourcing. And event sourcing and functional programming at the heart, these share a lot of things in common. And event sourcing and functional programming go hand in hand. So putting all of this together, this is how our code basically will look like. Yeah, first we have that Kafka consumer that will inject all the dependencies needed to execute any of the effects. Then we'll inject the state of the system. Then we'll be pulling using the Kafka pull API new events from Kafka topic, and then we'll calculate the next state and the effects to be executed, and then we'll just run those effects. Now, after building the system like this, we noticed some interesting things in our Java code. The first one is that our domain logic, all of our domain classes, they will have no getters and no setters at all. That was a little bit of a surprise. They will no getters, 0 getters at all. The second thing is our business logic will be a lot cleaner. because now there will be no logs or synchronized blocks anywhere on that domain logic. There will be no try-catch exceptions, and there will be no logging around our business logic, because all of those aspects will be executed, will be done by a different part of the code base. The other thing that we notice is that our test cases, there will be no mocks in our test cases, because all the logic was about getting as an input an event, a plain old Java object, and as an output to assert on a plain Java object. It means that it was very easy to test, and we didn't have to deal with any mocks or anything. Now, to test all the side effects, we actually had a handful of integration tests and full stack tests just to test that, connecting to database, connecting to Kafka, and all that kind of stuff. And because we have no mocks, that's also interesting, we didn't have any useless interfaces in our code base. By useless interface, I mean things like a typical interface that just have one production implementation, and they usually just create that interface just to make your test happy. This kind of style of design, it's called functional core imperative shell. In the functional core is where you have all those pure functions, and on that function, and you try to make as many decisions as possible on it. And then you have an imperative shell where you deal with all the messy details of the, interacting with the external world, and you try to make no decisions at all. And the idea here is to make the functional core as big as possible, because it's easier to understand and it's easier to test. Now, I know that there are a lot of architecture that look a little bit like this, and I want to point something that for me, it's important because I have seen it, all their presentations not getting it right from my point of view, is that if you have a piece of code in that functional core, like the client bonus that depends on some interface, and then at runtime, you are injecting something from the imperative shell that does side effects into that code, into that path, it means that that client bonus, that particular method that is using that notification sender, that doesn't belong to the functional, that's not functional, that belongs to the imperative shell. And this is not good or bad, it's just different. Cool, let's talk about the next difference between Java and Clojure. Java is a statically typed language, and Java is a dynamically typed language. So I'm going to show how a usual Clojure application looks like. First, your domain classes, they are just maps and lists of strings and numbers, or list of maps or maps of lists. That will be your domain model. And then once you have the domain model, what you will need to do, is just manipulate that data to, to build the logic that you need to build. Now, I don't know what you think about this particular piece of code, but for my Java sensibilities, it's very, very ugly. This is even disgusting. If anybody on my team have dared to commit that kind of code, I would say like, well, man, this is completely unmaintainable. I don't know what you're doing or what you're thinking, but just please revert this thing. So for our bonus application, we actually decided not to use the dynamic typing from Clojure, but just rely on Java type system. Now, once you have done Clojure for long enough, and you come back to Java, and you create, you create a new class like this one, your mind starts to dysfunction, right? And you start to have really weird thoughts. So you type this class, and then you notice a couple of things. The first thing that you notice is like, what functionality I'm getting out of this. What you're getting is a useless toString method, and then you get a broken equals and hash code. Thankfully, we have Lombok to help us with this, or the new value classes. But it's a little bit useless. But the other thing that you really notice is that, well, suddenly all the code that you have in your code base, all the code that is in the Java core API, all the code that's in GitHub, none of that code can do anything with your class. This class comes exactly with zero functionality. You cannot reuse any of the code that you have. Here's when you start to understand what Alan Perlis meant with it's better to have 100 functions operate on one data structure than 10 functions on 10 data structures. Every time that we create a new class, that's a new data structure that comes with zero functionality, which means that the reuse of your code is not good, or it's not as good as it could be. Now, if you keep your data as plain old data like that, the first thing is you get a nice toString method that is the one that you see there, and you get a sensible equals and hash code method. But the other important thing is that all the code and all the core APIs that you have in your language to manipulate maps, you can still use them. Yeah. The Clojure community has embraced this idea of representing as many things as possible as plain old data. So for example, who can tell me, well, what is that? If you look a little bit careful, I think it takes you like 20 seconds to realize that that's just an HTTP request. And now that your HTTP request is just plain data, it means that your HTTP server, what it has to do is get that map as an input and produce another map as an output. But not only that, you can represent also SQL statements as plain old data, or database result sets, or CSV files, or even HTML and CSS. You can represent it as plain old data, configuration files that are also plain old data, even metadata, data about your data, that's also, it's just plain old data. And the important thing here is that you end up using the same API, the same core API, to build your business logic, your infrastructure code, your configuration, even your reflection or metadata capabilities. You use the same API, so you just need to learn one API, and you can reuse code that you have. You can reuse code from the core API, or you can reuse code that you find in GitHub. Yeah? So after being with Clojure for a while, that dynamic typing that I thought it will be a big drawback is not that bad. It's a fair trade-off. Now, the other difference between Clojure and Java is that Clojure provides a dynamic development environment, while Java I'm calling it more static. So what do I mean by this? Let's say that you need to build a new functionality in your application. And the first thing as a Clojure developer that you do, the very first thing before doing anything to create a new functionality, it's to start the application. So you start the application, and once the application has started, then you start changing the application at runtime while the application is running until you get you finish your feature, and you get a really, really tight feedback. And you manage to do this with a REPL. And Java got a REPL, but the Java REPL and the Clojure REPL, they're two completely different tools. The capabilities are completely different. With a proper REPL, you never have to start or restart or package or compile your application. You start it once at the beginning of the week, and then you just keep modifying and changing it, making your application within, you modify a living application. When a REPL, if you have a proper REPL, it's a little bit like having the ergonomics of a bash shell, but having them in your production language, in your production code. A REPL is a little bit, it feels like a debugger that is always available for you, always attached to your running JVM. It's like a little bit like having a Google Chrome, the developer tools, but on your production code, on your production code base. It's a little bit weird, and I have a whole talk about how it feels and how you do it and all the possibilities that it has. So if you are curious, I encourage you to look at that. Cool, last section of the talk. Lisp versus Fortran. Java is the Fortran family of languages, while Clojure is a Lisp. Yeah? Obviously, for this application, we decided not to use Lisp syntax because I will not be giving even this talk if we have decided that. Now, for all of you that run screaming whenever you see a bunch of parentheses in Lisp, I have good news for you. The first good news is that in Clojure, the same in all modern JVM languages, semicolons are optional. Yeah? And we know that this is a huge productivity boost, right? That's just amazing. And in fact, it's so amazing that Clojure goes one step further. And in Clojure, commas are also optional. So imagine all those millions of commas that you type every day. If you didn't need to type them, you would be a lot more productive. But I know what you're thinking, right? You're like, what about all those pesky parentheses, right, that Lisp is so infamous for? Well, even here, I have good news for you. These are two pieces of code that one of my teams built. When we were learning about Apache Spark, we happened to build the same application twice, one in Java, one in Clojure. And there, what you see is basically the core logic of those applications. Very simple. But there is an important difference between both pieces of code. The Java version has 60 parentheses, while the Clojure version has 10 parentheses. So if you work with Clojure, you not only have not to type semicolons or columns, you also type a lot less parentheses than in Java. Now, there is something more. For this particular application, one of the things that we notice is that the Clojure version of the application wants 1/10 of the code base, the size of the Java application, 1/10. So just imagine if you could get 90% of your code and just throw it to the bin. Now, enough of silly jokes. I'm going to try to explain why Lisp people really love their parentheses, right? And for that, I have to show you another piece of Java of Clojure code. And so this is a piece of Clojure code that what it does, it creates a new function called +1 that accepts 2 parameters, A and B, and it returns a map with the time of the computation plus the result of A and B +1. Yeah? Obviously, this is not how you write Clojure. It's a lot more, a lot shorter, but this is in essence what you are doing. And if you look at it, what is this that you are writing? Yeah, you have a list of with that contains some kind of type that is a symbol, and then you have another list, and you have a map of keys to values. So this is just plain old data. So when you are typing, when you're writing Clojure or Lisp, you are actually just defining plain old data, which means that to do metaprogramming, so to write programs that write programs, or to write programs that generate programs, or modify programs, to all that metaprogramming that you know, it's so powerful in Lisp. It's just about changing, it's just about working with plain old data. It's not something special. And you do that with the same API that you use to build your business logic, to build your configuration or your infrastructure code. And this is the reason why Lisp people, they're so in love with the parentheses. So in summary, try to follow. I think I found that following this design actually comes with, with cleaner code bases. Yeah? Try to make that functional core, pure functions, as big as possible, and then you just have a thin imperative shell where you deal with all the messy details of the real world. After working with Clojure, I'm not so sure that, I understand now the trade-off between dynamic and static types. But after enjoying Clojure's dynamic development environment, this is the thing that I really, really miss the most when working with Java or with anything that doesn't give you an immediate feedback. And please, don't be scared of parentheses. The same way that you will never dream of writing any Java code without a proper ID, it's the same with Clojure. You have there the ID that will take care of all those pesky parentheses. And there's a good reason for those parentheses. And I want to finish with another quote from Alan Perlis. A language that doesn't affect the way that you think about programming is not worth knowing. And for me, Clojure has been one of these languages. Functional programming, immutability by default, Lisp syntax, macros, all those things have been big lessons on my career, and they have affected how I build applications, how I design solutions. Now, none of this has been Clojure's most important lesson. The biggest lesson for me learning Clojure has been how close-minded I was to anything that didn't look like Java. Yeah, if it didn't look like Java, I would not even bother to look at it. If any of you have told me like 5 or 6 years ago to look at the list, and not any dynamic list, a dynamically typed list, I would say like, well, man, don't waste my time. Yeah? But here I am preaching about Clojure. So I want to encourage everybody for this year to learn a new language. It doesn't need to be Clojure, but learn something that is completely different from what you are used to, something that is completely alien, something that is, weird. Yeah? I'm sure on that journey of learning a new language, you will find something that you will bring back to our day-to-day job as a Java developer. And in the worst case, it will just make you weirder and harder to relate to. Thank you very much.
Okay, thank you.
Before we leave, I have one more slide.
Yes.
Yeah. If all of you, if you have been completely asleep or working or playing while you're looking at this, I just need you to pay attention to this one particular slide. Yeah. The other one, it's not important, the rest of the talk. Yeah. Are we focused? Okay.
Perfect.
Thank you.
Thank you, Dan. Thank you, Dan. It was really a nice presentation. Thanks so much. I hope the audience enjoyed it as much as I did. So this was our last talk for today, and we have also a question to you, Dan. So very general one. I think it is also a bit covered by the presentation already, but still again, like Mr. Anonymous is asking, what are typical use cases for Clojure, and when and why Clojure is better than Scala?
Okay, typical Clojure is a generic. It's anywhere that you will use Java, you can use Clojure. It's true, and this is so people don't. It's true that Clojure in general is between 10 and 20% slower. So you will sometimes need to, look at that performance if it's really, really critical for you. But in general, you can use Clojure for exactly the same things that you use Java. Plus, there is a Clojure dialect called Clojure script that compiles to JavaScript. So you actually, you have that reach of Clojure scripts. And anywhere that will use Java, you can use Clojure. And why Scala? I don't want to get into this is a personal preference. Before learning Clojure, I actually tried to learn Scala, not once, but twice, and I failed both times. So it just maybe means that I'm a little bit dumb, but Scala didn't stick for me, and I found Clojure a lot simpler. And in my career as a developer, I have always gone for the easy stuff. So that means that I pick up Java, honestly, because it was easier than C++, and you don't need to deal with pointers and everything. I pick up backend developer because I think it was easier than front-end development, and I pick up Clojure because I thought it was easier than Scala, at least for me, and easier than Java, personally.
Okay, that's a good answer. Also, that it's like just a personal choice. We have these questions of this type quite often, like why this language and not the other one, or this tool and not the other one. I would say the answer, as we had it already this today a couple of times, is always it depends. It depends on what project do you want to do, what do you want to achieve. Is security more important than performance? Is coding speed or time more important? Or at the end, also the personal preference, I think, is a big factor. So if you don't feel comfortable with some language or framework or whatever, then get another one. So I think there is multiple ways to do and finish stuff. So Dan, thanks again. So we are slowly closing our Java Day for today, but I have two more things that I want to share with you. So first of all, if you are looking for a job, or if you just want to see what is out there in the market in Europe, please visit readevelopers.com. You will find thousands of jobs there. Maybe there is something for you as well. And the second thing, also very important, as I said in the opening of the Java Day, this is just the beginning. This is just our first day for our first event in this year. In 2 weeks, we will have the Container Day. We will talk about Docker, about Kubernetes, about cloud tools. Very excited for that. And in 4 weeks, we will have the Python Day. Also super interesting, so stay tuned. Join us again in 2 weeks. And with that said, stay healthy, stay safe, and goodbye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On wearedevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.